you will enjoy not only the conference, but also take a chance at seeing the competition downstairs and in the marina. It should be a very, very tough challenge, exciting challenge. I understand that there's a lot of innovations and some tricky ones as well on the sea. And in order to welcome you, I would like to call on stage Charlotte Mille, who's the Sustainability Manager for Yacht Club de Monaco and the head of the Monaco Energy Boat Challenge. Please welcome Charlotte. Thank you.
Hello everyone. First of all, I would like to thank you all for being here with us today. We are very keen to speak about those subjects of alternative fuels and the future of yachting here at the Yacht Club of Monaco. I'm just here also to invite you to not only attend the conference, but also visit our paddocks and discover what the young generation is working on. We have over 40 universities present between the prototype and also presenting their project in the hospitality units. They're working on alternative propulsion systems. Some of them are working also about thinking about life cycle assessment. They're working about eco-conception. They're thinking about the design of their boat. And they are your future employees. They are your future bright minds that you want to hire and that you want in your company. So really, I know you're here for the conference, but take also the time to go and meet them and visit the paddocks, and I'm sure they will appreciate to meet you. Thank you all again. I hope you have a good conference with us, and thank you for making the time with us.
Thank you, Charlotte. So in order to get started, without much further ado, I'd like to call on stage Giuseppe Zagaria, who is the Marine Technical Director from RINA. Hope he's here. Yes, he is. Please welcome Giuseppe on stage, and he's going to give us the first keynote, which is about, the first panel session will be about methanol use in yachting. And so Giuseppe is going to give us an overview on the regulatory landscape. Thank you.
Thank you very much. Good morning, everybody. I think I can use... Yes. So, good morning again, distinguished delegates. I will not take so long from your time. I have this keynote about methanol. As you know, it is extremely very promising solution in order to move the yachting into net zero. This is something is already happening since many years for the traditional shipping, but we see already some very important shipyards. They start to invest heavily on methanol solution. What you can see here is the so-called 5 pillars that need to sustain a methanol ecosystem, because as you can imagine, shipping and yachting, they don't have that magnitude to move the whole industry, okay, into methanol. These are 5 pillars that we should take into account. Of course, there are also challenges that we need to tackle. So first of all, we need a proven, okay, and a clear regulation framework. So far, we have something available from IMO. Some shipyards are having some, struggling, okay, in order to adapt this regulation, because as you know, IMO produce this circular guidance, but they don't have in mind clearly how a yacht works and how a yacht is designed. So, the heavy part of this job is to adapt the documents available so far from the shipping to the yachting. We must have a reasonable production of a green methanol, because as you know, we have to take into account the final cost of methanol that we bunker on the yacht. So if green methanol does not reach an affordable price, unfortunately we cannot bring we cannot bring green methanol on board. We must have a straightforward and clean system that makes sure The green methanol that we put on board is properly certified, so the ship owner has to feel comfortable, okay, to ask for green methanol certification. We need to retrofit the existing supply chain in marinas in order to have, methanol anywhere the yachts may need. And finally, as I said before, we need more industry sector that should move to green methanol, because this will increase the demand, this will increase the production and converge into a lower cost. You can see this is an estimation chart about the whole transportation sector. So methanol will play some role. Here you can see basically is the green color. Inside the liquid fuel renewable, there is green methanol. So we are sure green methanol will play some role, but from the theory to the practice, as you may imagine, shipyards need to have on board proven solution. So we believe the winner will be who start to invest today on standardized solution, okay? Shipyards cannot every time think, as a white paper. So it is now the right time, and we as a classification society, as ARENA, we are very happy to work together with the shipyards to fix some solution accepted and safe for new buildings, but also for retrofit. Finally, this is a sort of forecast. We do this exercise more or less every 5 years. So if we compare with 5 years ago, today we are much more positive, okay, about the role of methanol that is going to have in order to move the yachting into a net zero. As you can see, some years ago there was some gap about the supply. Now you see some announcement about some industry, some facilities that will soon start to produce green methanol. Technology also made very important steps ahead, and of course more products are available on the market, and shipyards may have more choices. That, as I said before, it is extremely important to have a reasonable amount of choice, but also an affordable cost. I close here my keynote, and I thank you very much.
Thank you. Thank you, Giuseppe. No, don't leave the stage. Don't leave the stage. Please stay on the stage, because you're going to be joined by our panelists from the shipyards, who will be presenting to us their projects, the ones that have been working on the incorporation of methanol fuel cell on board. So they'll join me on stage and join Giuseppe to make these presentations very quickly, of course, so that then we can have some questions and discuss the topic, because as Giuseppe correctly pointed out, there's some benefits, there's some important improvements in the adoption of methanol, yet there's lots of challenges, and we'll be discussing these. So in order to start the panel discussion, I'd like to call on stage Daniel Chatterjee from Rolls-Royce, who's the Director of Corporate and Sustainability. Bernard Urban, who is the Head of Development and Innovation at Lursen. Paolo Bertetti, who is the Vice President Technical and R&D at San Lorenzo. Stefano Di Marco, who is the General Manager Sales Varsila. And Giuseppe Zagaria is already on stage. So, gentlemen, welcome. Thank you for being here. A quick reminder, at the end of the session, we'll be taking a photo, so please don't rush out too fast. So we'll do it in the order of appearance, with Daniel making his initial introduction, followed by Bernard, Paolo, Stefano. Okay? And here's the clicker, and you've got a mic in front of you.
Yeah, warm welcome from my side, and short introduction to what we're doing at Rolls-Royce, or maybe you know more our product, MTU. So we are a propulsion provider, but not only for yachts, and because we're talking on energy carriers and fuels, I'm just giving you the big picture. So we're producing, actually at Rolls-Royce, also aviation turbines and many other applications. So choosing the right fuel is a critical topic for us. And you see most of those applications require significant energy densities. That's why these are all the applications. You will probably not power fully electric. And when it comes to yachting, clearly what the roadmap we see is, and that's actually underway, that the really first step is that we go for hybrid solutions. So making actually what today you have a mechanical drive, you have gensets, to make it to more one power system. So that basically you have still engines, but actually you provide electricity and then you distribute it for propulsion or hotel load. And that combined with batteries allows you at the end to have at least in the harbor completely emission-free operation, or also you can switch the operating points of the engine and gain efficiency. And that's something we see in yachting already. Also, let's see, from our perspective, we have now meanwhile very commercialized those approaches. So we have it also in commercial shipping, a lot of projects. And clearly, and the topic what you use here is, because it's still diesel driven, is the topic of HVO. And I think that's something which is really ramping up very fast. So HVO, if you don't know, it's second-based generation biofuel, or it's a synthetic diesel fuel made from old fats or whatever. So I think that's already a very good solution. But, and everybody asks, yeah, okay, we are done. We're using HVO. But you need to keep in mind there's not enough feedstock. So if you use fats, you will maybe limited around 40 million or 50 million tons producing capacity. With other features, you can go higher. And the next step, and that's maybe the big debate, when will it really come in large scale? We see methanol. That's why we are here. So methanol is really a kind of a sweet spot, we think, for maritime industry, especially for yachting. It has only half of the energy density, but it's handleable, and we heard in the keynote there are also some standards. So we believe really methanol is, let's say, the next fuel is coming, and maybe I should write 2030 or later, because that's the big debate. At the moment we see a delay in the projects to produce methanol, but still a lot of momentum, as we heard. And that's why we are at the moment in the development phase of developing a single fuel methanol engine, so which we believe will give the highest efficiency for that. And it's currently on the test bench, so it's not in the ship yet, but I think that's for us really the roadmap, that methanol will become the next fuel. Thank you.
Thank you, Daniel. So next to talk about how they see methanol being used in yachts is Bernard from Lursen. I'm sure you already have plenty of questions in mind. I do.
Okay, good morning from my side again. I'm very happy to be here and to present to you our roadmap for CO2 neutral yachting. I'm with Lursen for almost 20 years now, and I started at Lursen with the first project dealing with fuel cells, which you can see here with our research activities the last 15 years or so. And also, like 15 years ago, we decided that methanol will be a major fuel that we are looking into. And most of our research projects were dealing with fuel cells. And during those activities, we decided that the low temperature fuel cell will be the way to go. And within one of those research projects, we built up an innovation lab with the fuel cell. And today we are having our first project, a yachting project with fuel cells on board. And this is an add-on installation. Next steps on the roadmap will be that fuel cell will replace normal generators, And on the long term, of course, we hope that sometime soon that we have a fully fuel celled powered yacht. A few more words on our current project. Most of you might have heard of it. It's the Cosmos yacht, which we are building in Rendsburg. And we are installing on that yacht 2 fuel cell systems with 500 kilowatts each, so a total power of 1 megawatt. We have the 200 cubic meter methanol tank on board, so we have 15 days independence at anchor that we are have a carbon neutral operation. Or on the other hand, we could have 1,000 nautical miles range at low speed. So that's a short introduction from my side, and I would hand over to Paolo.
Good.
Thank you, Bernard.
Good morning to everybody. I was here already last year. We spent some time with Laurent talking about methanol, and there was a promise. The promise was we will have 2024 the first yacht with a fuel cell with methanol. So you will see that in September here at the Monte Carlo Yacht Show. But that is the reality today. What I would like to say you this morning is the point that we have to consider is having targets for what we have to do. So we are talking about methanol, but before talking about methanol, the point is yachting has not yet rules from IMO defining the route for the decrease of emissions. So we decided to set our own target, and the idea was to be faster than shipping, because we are, let's say, an industry that is quite fast to react. So as you can see from the overhead, our idea is to have the net zero line in 2035. And another target is 80% of carbon neutrality 2030. It's very challenging, but we have to start from a target. Otherwise, you have no idea what the speed you need to reach it. So, and how to do then the strategy? Our strategy is divided in 3 steps. The first step, 2024, is to have a first application with a methanol fuel cell that can bring on board the power needed for the hotel loads. And this is what we have achieved. Then 2028, we are targeting the first application with B-fuel engines. So not only hotel load, but even propulsion, where we can either have a B-fuel engine or an engine with enough power. Could be even genset for the diesel electric. Anyway, propulsion with B-fuel engines. And then 2030, 2035, having again with methanol engines and or high power fuel cells in order to have even with fuel cells enough power for the propulsion. Seems really simple. In the reality, we have to consider that we have not only issues with the technical details, so it's not just engineering what we need. We have basically 4 other areas where we have to win if we like to win the challenge. So let's say the yard technical competence, we have started. We are not alone, so we have here Lursen, we have here, I see even Fedship. So all of us are working very hard in order to gain inside the knowledge that is needed. Then we have the technical partners, MTU and others, where is needed really a lot of effort from their side in order to give us the engines or the fuel cell or what else. And let's say between yards and technical partners, I think we are more or less middle of the way. So we have not to relax. We are still not at the target. And then we need even to involve the owners and the crews. That is really a big issue. If they do not have confidence, then we can create very nice pilots, but then the extension to the market will be difficult. So we have to work a lot on that, to create the knowledge of what we are doing and to give them the confidence that what we are doing is good, is safe, is reliable. Then another area, authorities. Here the point is not all the rules are already written. The first point that we have in mind with all our partners in the other yards, cofferdams. That's a big issue. Means that on a yacht where we have very tight spaces, we have to dedicate a lot of space for air. We are working very hard with the register here to find a reasonable way of preserving what is the task without losing space. And then the last point is availability of fuel in ports and marinas. This seems to be a negligible point, but is not. I remember 2-3 years ago, there was a lady here, I don't remember the name. She was the first one to have built a small yacht with hydrogen. She was from Monte Carlo, or area here around, and she was crying, no way to have methanol in the ports. And I was saying, strange, sounds not possible. Now we can realize with methanol is the same, it's not so simple. So really, and I will stop here, the challenge to reduce emission in yachting can be winned, but we absolutely need not to focus just on the yards. We need strong support from all of you. Otherwise, it will remain not a dream, but a target that takes too long time to be achieved.
Thank you, Paolo. And last but not least, Stefano.
Thank you so much, and thank you so much for the organization having invited us here. My name is Stefano De Marco, and I'm serving in Varsila since '96, several different roles, and now I'm heading the business development in the Mediterranean area. We're here not that much to talk about product or solution, but we want to give a little bit some hints about our approach to the methanol. I link to the words that Paolo was saying before. Solution must be good, safe, and reliable. And this is something really crucial and fundamental. And this we were experiencing since quite a long time on the methanol. We initiated our research and development on this kind of fuel more than a decade ago. And okay, it was on a commercial vessel, but we were envisaging already that time that there was a possibility, a future of this kind of fuel as a potential alternatives in envisaging the decarbonization the maritime industry would have faced in few years ahead. This is one of the alternatives. I mean, methanol said already before, there are others, but we saw that on the passengers and yachting and cruise, methanol can be a viable alternative. We as a Varsila are representing a technology partner for the industry, but what we want to be seen a little bit in a different manner, not only as a supplier or a stakeholder for the industry, but more as a partner, because we want to accompany, we want to support our customers in developing their target, their idea, their dream in the future. And this is something that we think is really crucial, because in many ways the industry is facing difficulties to find proper standards and so on, and so we want to support in developing the idea and project in that sense. We know that there are complexity in developing these alternative fuel. Here there is a snapshot. I'm not entering in the details of these, but what we want to explain or underline is that we as a technology partner are supporting the concept of the flexibility. Paolo said before, finding fuel around the world is not always a walk in the park, and there could be a hiccup or problem, difficulties on retrieving proper fuel. So having a system integrated that can provide proper flexibility of using one type of fuel or the other, depending on the availability and depending on the operational profile that the vessel is developing at that very moment, would be really crucial. And this is a little bit our scope, our task also in the yachting industry, in the yachting market. So what we are promoting is really the approach of the flexibility and so forth. This has been applied also very much on developing our roadmap and our portfolio, giving priority where the customer is having the highest interest. That's all from my side. Thank you so much.
Thank you. Thank you, Stefano. So if I try and recap briefly all the things you've all said, methanol seems to be, in a way, the sweet spot, as you mentioned. And the fact that you can look at developing your projects with a bit of flexibility, so that's the idea. Whether you combine hybrid systems with diesel at the moment, but then turning to methanol, using fuel cells for maybe hydrogen gensets in the future. And the fact that using methanol is a very good solution for retrofitting existing vessels is also something of interest. Just for everyone to understand, because there's been mention of fuel cells, and when we talk fuel cells, we think hydrogen, so this could be a bit of confusion. So just to clarify how it works, just do it very briefly, is that technically speaking, methanol is the fuel that is available at ambient pressure and temperature, and then on board the boat it is converted into hydrogen through steam reforming, so which adds another device to the setup, in order to be able to have hydrogen then running through the fuel cell to produce electricity and power generators, basically. Just to, if I'm correct. Yep, okay, good. So I have already a few questions for you. You've been working on projects incorporating methanol. What has been your main technical challenge? Whoever wants to answer first, between Daniel, Paolo, Bernard.
So far, the main challenge we have faced is space. It's clear, you need more volume for the same range, 2.5 times roughly. On top of that, you need cofferdams. So really, in a yacht where the space for the tanks is really the space that is remaining after the architect and the engineers have used all the space for accommodation and engine room and what else. Really, to squeeze there the quantity of methanol with cofferdam is a big challenge, and when you are looking to yacht in the range between 50 to 70 meters, that is our range, it is even more challenging. So that is the point number one. And then point number two, really the interpretation of rules with the registers. I think that this is really a point where we can spend a lot of time discussing.
I would agree totally to what you said, Paolo. The first aspect regarding cofferdams and the space for methanol is difficult, but something that we can handle, that our engineers can build. But the main challenge actually is that nobody has experience with those rules. And so there were a lot of discussions that we had in Rendsburg on how to design the systems, because nobody had any experience. We didn't, the classification society doesn't, flag state doesn't, so it's very awkward situation sometimes. And there we had a lot of discussions, and there we need to get some more confidence. And of course, we need to have a solution for cofferdam, because that's not a good solution, having a lot of air carrying around and losing a lot of space.
Yeah, so not giving a lecture on combustion engine right now, but I think the main challenge we see is, so methanol is a low flash point fuel, so that brings you on your piping system different aspects, but clearly, and that's the difference, because for two-strokes engine, for example, methanol is already there. We are talking now here for yachts and high-speed engines, so topics like knocking, methanol has not the same lubricant aspects like diesel has. So these are things, and the good thing, I think, we can handle that. So this is development work, and there are no injection systems at the moment out, so we need to develop them with partners in the range we have. So that's a bit the good news, and the good news is also we have a gas engine for maritime application that's actually a good starting point for low flash point fuel. So I would call it more an evolution, but maybe we'll come there. So we see more bit the challenge, the whole topic, methanol ecosystem.
Thank you. So when you say technical challenges, obviously they are pretty much mastered, but how is the difficulty of the fact that you've got to anticipate, in a way, dual systems? You talked about biofuels, you talked about combination. Is that something that is difficult nowadays when you incorporate methanol with other solutions, or is it technically not so much of an issue?
Now, let's say, it's one of the topics that you need to take into consideration. Experience is providing you peace of mind. We are dealing with the dual fuel system since mid of 90s, so we gather a lot of experience. We do understand that eventually reciprocating engine is having proper development as such, and the automation system is supporting very much this, because it's a sophisticating activities in the combustion system that we are applying to the engine. But this is a proven technology, and this is now a really a bread and butter for the majority of the players. So when the customer is having in mind to initiate such a kind of endeavor, can start with proper comfort in that respect. So dealing with the multiple fuel, it's now a new standard.
Thank you. When it comes to customers, I was asking about technical challenges, unless Paolo, you have something you want to add?
Yeah, just to add one comment. As an observation point from the yard's point of view, B-fuel or dual fuel is a must, because you cannot consider that all the marinas will have methanol available in the next 5 years. So you need to have dual fuel or B-fuel, and then the ball is in the hands of engine manufacturers. And there is the big issue, because engine manufacturers are working a lot to develop many applications at the same time. They are working on hydrogen, they are working on B-fuel, they are working on full methanol. That means a huge amount of time and money to be dedicated. And that is affecting speed. Because from our side, we are saying maybe B-fuel is a must. Then from the commercial, they have other issues. And then we are pushing for small engine and fast engine, and maybe in the same desk there is the request for commercial engines. So that is really the big issue we see. And unfortunately, the engine manufacturers do not have enough resources to do that as fast as you would like. And that is creating a collateral effect. They are going outside looking for someone that can support them in the development. And there is a wide range of possible support. You can have small companies that are basically already active to transform engines for B-fuel. On the other side, you have the maximum theoretical guys. What we need is something in between, because if you are too, I would say, too practical, there is the risk that you are not considering all what is needed. If you are too theoretical, like consultants, they are very good to define from a stoichiometric point of view what is the best option, but then you have to build the engines. And then the engine manufacturers are going in trouble. So today I would say the main issue is time and prioritization, because the brain is a good one. So I'm totally confident that is valid for MTU, but the same is for the others, and all are working on that. Timing can become an issue.
Thank you. So when it comes to, you were talking about the customers, so let's have a quick word about that. When you talk to customers, whether for engine manufacturers, is to shipyards, or as a shipyard talking to the end client, was the perception or the reception of the fact that you're offering methanol fuel cell, is that something that they actually now understand better and are willing to accept a lot easier, or it's still a difficult challenge?
It's still a difficult challenge, of course, because we are just about to build our first project. It has not been delivered yet. It has not been commissioned yet. So I think as soon as we have launched the project and we have gained experience and have confidence in the system, then this will pave the road for new projects and for further development and optimization of the fuel cell system, of tank system, bunker system, cofferdams, etc., to get an optimized yachting design with fuel cells on methanol and maybe some hybrid systems, including that.
Thank you. Yes.
Yeah, just I would like to add a comment, because we spoke about fuel cells engine. We know for sure that in the midterm, methanol can be a protagonist for decarbonization. Actually, there is a very interesting advantage that only methanol has. We know the solution is the mix, but can be, no matter is an engine or no matter is a fuel cell, you can use methanol. Only methanol has this advantage, okay? Because if you think about diesel, not really. Hydrogen has its own cost for storage. So if you put on the balance from a cost point of view and from a technology point of view, and how the methanol can be flexible about the users, only methanol, has that part, because with a reformer you can put in a fuel cell, or for an engine is already existing right now. So that's to highlight, this kind of advantage that only methanol has. Thank you.
Thank you. So it's a good question. The next one is for you, in fact, as a regulator. Yeah. Okay, there's been discussions, the fact that things need to be put in place, but I would say that technically nowadays, being able to commission a yacht that runs on methanol shouldn't be an issue from a regulation standpoint. It takes time, but it is feasible. As a regulator, how can you then help push for the infrastructure to develop? Because from what I understand, this is also one, we're not talking about the fact that you need to have the crew and captains trained. I mean, we know that it's something that's going to come along. But one of the issues seemingly from the various shipyards is infrastructure and refueling infrastructure. I can share a very simple experience about that, and the fact that in Italy, at the moment, getting any alternative fuel, whether it's hydrogen, whether it's methanol, is barely, is practically impossible to be able to get to refuel because of the port authorities, the public authorities, making it complicated, if not impossible. To what extent do the regulators work with the public authorities, or can push or help with the shipyards to drive this forward? Especially because, as you all said, methanol, for the time being at least, is a sweet spot.
Thank you for giving me this question. Okay, so first of all, personally, and to represent a class society, I think all of us in Ajax, we feel very I mean, we appreciate very much the challenge, okay, from the shipyards, the push that they're giving us, because it is our job to sometime to build, you know, a safe regulation framework. On the other side, we are doing also, I mean, consultancy work, advisory work with the local port authorities. I have to say that it is not, I mean, they don't have all of them the same mind. Some port authority, they are extremely, let's say, they think from, I mean, more to industry point of view. Some other port authority, or maybe at a central level, you need sometimes several meetings, okay, in order to give them a proper perspective. Of course, if you talk to them, you know, they are always able to highlight the reason that they may have, because we need a proper care, you know, we don't have to go I mean, extremely fast, because at the end of the day, on the yacht, on the ships, we have to protect the people. So yeah, there are these difficulties right now, but I may tell you there are big associations that now they are moving in order to give, I mean, enough pressure on the institution. I'm talking about, I mean, Italian Ship Owners Association, Marina Association. So from institution point of view, compared with last year, now the channel are open, and I think in the next 1 or 2 years, the situation will be extremely, I mean, much. I can give you an example. When we have cruise ships fueled by LNG, you know, an institution, they don't issue a guidance if you don't have ships. So when, you know, we have this kind of market in the Mediterranean Sea, and some ports in Italy, they start to have that kind of request in the, I mean, in a certain way, they finally issue a guidance. Some ports, and now the others, they start to, you know, copy that sort of approach. So I think it's moving in the right direction right now.
Okay, but is the timeline, as Paolo said, fast enough, in the sense that when you think about LNG, it's taken over a decade for things to move forward. So to what extent you are confident, all of you, that the adoption of methanol will be something that can happen faster? I mean, 2030 is like tomorrow, then.
Yeah, basically, I think it's important to get a bit the bricks of the timeline together. I think you mentioned it. So at the moment in maritime, there are around 220 ships into order, methanol ships. So production capacity is 16% at the moment of what we have in grey methanol market. So I would say the signals are clear that methanol will come. So that's where I'm completely positive. On the other hand, you see there's a ramp up, and if you just count how much methanol will all those, a lot of container ships will they consume. They will consume more than the 16%. And if you look in the project pipeline, there's already a gap of final investment decision for the production of 14 months roughly. So there will be a delay. But basically, our view is methanol be maybe until 2030 will mainly go to the big ships, but this will scale up. And then in the next decade, and also will bring costs down, that's then the option. And I mean, yachting is not at all consuming, so there will be before options to get the fuel, but then it will get bigger. So I think that's how we see. So there's some delay at the moment because the production FIDs are not there, but because the ships are in build and there's a lot of push from the big companies, that's where I guess also we at the autumn can have the confidence methanol will come.
If I may chip in on what Daniel was saying, really the customers that are representing the consumer, ship owners are representing the consumer, can make really the difference also in this specific case. And as Daniel said, large operator, the container liner companies can really be the front runner and represent the critical mass in order the industry can initiate the production of methanol. So we need to, if you look to a deadline, or let's say a time ahead in the horizon, we need to look those operators to see where the market is oriented and where the new possibility for methanol in this specific case will be. Close by, we hear 2028 in the area of Toulon, that there is something that is boiling over there. You know, there are CMA-CGM to mention, there are other ferry operators that are all having these alternative fuel in their roadmap, and they are see this one for the decarbonization means. And you can be that if those guys are putting all together and cooperating, something will happen there. Huh?
Thank you. A couple of minutes for questions from the audience. We haven't spoken about biomethanol and green methanol and biomass matters, and but I don't know whether there'll be any question about it. Okay, there's a question there, and I don't know where the microphone is. So if the microphone is not around, I'll give you mine. Quick question.
Quick question for San Lorenzo. You mentioned that San Lorenzo aims to be carbon neutral in any condition by 2030, but then you also said that you don't foresee that ports and marinas will have any methanol available in the next 5 years. So I was wondering how you can reconciliate those two points. Thank you.
So the point is that you have to consider a flexible and pragmatic way to bring the methanol in the marinas. So if you are waiting to have the refueling station with the methanol in the tank on the ground, that will take long time, because basically it's a business. You need to adapt in some way the piping and the tank and what else, and you're not going to invest because there are so many users that at the end you have no return of the investment. But there is an easier way, that is bringing the methanol with a small truck inside. That can be done, let's say, faster. Then this is linked to the authorities that should allow that. So I'm quite confident that we can solve it, and I think that the speed of the process is going to accelerate in the next years, because if we look just 2 years ago, talking with the engine manufacturers, they were not so hot with the dual fuel, they were not so hot with a lot of development. After 2 years, all of them are working very hard to make it happen. So in 2 years from now, I think that the authorities and let's say the politicians will probably be more active than what we can expect today. So I'm quite positive on the future.
Thank you. And yeah, one last small, short question, please.
Thank you. Very quick question to the shipyards on the current order books. What is the rough percentage of orders for alternative fuel vessels?
So for a listener, I can say that we have this one project with the fuel cell. And as soon as this has been delivered and we have gained experience and confidence, I believe that many projects will follow, but we have to wait until this has become reality and that we have gained experience with that. But we still experience interest in the market, and every project has there's a discussion on that. And also there's a discussion on building a methanol-ready yacht, but this is also linked to what Paolo said, cofferdams and so on. We have to see that the space for the methanol in the future is not too big on the yacht in the end.
Laurent, if I can add an additional comment on what was said by Bernard. I think that you need to have a case to show. So I totally agree what he's saying. When you have a first boat there, then you can create more interest. For sure, take into account that clients are quite sensitive in principle. What means in principle? If then the captain is saying, I'm not convinced that is a good idea or is risky, then the owner is stepping back. So I think that having case on the dock to show is very important, but we have to work a lot on crew and captains to explain what is the reality, because they are scared. When they see how you have to refuel and look to the specification, then they are saying, my goodness, it's like refueling a rocket. But at the end, it's not more dangerous than gasoline.
Exactly.
So the point is, today we are maybe scaring the people, scaring the crew with a very complex procedure. But again, I'm positive in my life, I'm always positive. I'm saying that can be done. For sure, we have to understand that this is an issue. We have not to forget it.
So basically the message is that if anyone running a yacht management company and giving training to captains and crew should start thinking about training them with the use of alternative fuels is a very important aspect as well. Thank you, gentlemen. Much appreciated. Please just stand around here so that we can have the photo taken. And I would like the audience to give them a big round of applause for their discerning explanation. Of course, we're going to have a coffee break afterwards, a bit later. So you have plenty of opportunities to also talk to them individually if you've got some additional questions. I think it was very insightful, gives a lot of scope, and we're going to continue with our second panel, which deals with another alternative fuel that is not so well known, I would say, as compared with the methanol or hydrogen or HVO and other e-fuels. It's ammonia. Ammonia has been a big topic within the shipping industry. We talk about LNG, we talk about ammonia, obviously methanol. And ammonia is a solution that could also be of interest to yachting. So for that roundtable, we're going to start with another regulatory keynote, in a way, that can introduce and explain what is the regulatory framework for ammonia. And for that purpose, I'm calling Antonio Bonacorso, Technology and Innovation Manager at Bureau Veritas. He's going to deliver a short keynote about ammonia. Please welcome Antonio to the stage.
So, good morning to everybody. First of all, I will say when I have been asked to talk about ammonia, I said, wow, ammonia on a yacht, it's a good challenge. So I will discuss briefly about ammonia as marine fuel. Let's start. Ammonia. What is ammonia? Ammonia is a toxic, colorless gas, liquefied for storage and transportation. It has a pungent smell, and this is an issue for sure. And at atmospheric pressure has a condensation temperature of minus 33 degrees and a dry ice temperature of minus 70-90 degrees. It has a flammability range between 50 and 27% in dry air, and the combustion does not produce carbon. Ammonia is one of the most promising carbon-free fuel with no CO2 emission or GHG emission, provided that the combustion is controlled and produced out of a renewable source. One of its two precursors, the nitrogen, is widely available in the atmosphere, thus it can be produced from any location with a free and high concentration. The ammonia transportation at sea is nowadays mature with a robust safety handling and a loading-offloading procedure. It is not so cryogenic, and one of the other advantages is the trading commodity. On the other side, some challenge of the ammonia and the key consideration are the combustion, the volumetric energy density, the toxicity, foul odor, competition with other industry and alternative fuels, the green production. This is an overview of ammonia as fuel. We already say that it is highly toxic to human, lighter than air when dry. The ammonia vapor is heavier than air in a wet, humid condition. It is corrosive. From technical point of view, the tank size against the conventional fuel oil can be a challenge, because for the same energy we have to consider more or less 3 times. The ammonia engine are not always available in the market. They have been announced between 2024 and 2025. From an environmental point of view, the well-to-wake GHG advantage is noted. It is toxic to the aquatic life, and one another concern is the possible combustion by product NOx. From IMO regulatory framework, we can say that for gas carrier, ammonia as toxic cargo is not allowed to be used as fuel as per chapter 16 of AGC code. For the other ships, there are no detailed requirements, but a full alternative design approach is applicable as per SOLAS and EGF code. BV has issued its own rules for ammonia-fueled vessel. There are the NR 671 released in 2022. From IMO, there are guidelines under development, and the basic test is available from the CCC9. A few words about BV rules for ammonia as fuel, the scope and the principle. Compliance with the IMO EGF code and BV rules for gas-fueled ships is required. Specific requirements in connection with the properties of the ammonia are also taken into consideration, mainly its toxicity. About the principle, the release of ammonia is to be limited to the lowest practicable level. Direct venting of ammonia to the atmosphere is not permitted in normal operation condition. Venting of ammonia for control of the storage tank pressure is not acceptable. A venting of ammonia to the atmosphere is permitted in failure condition, provided it does not result in dangerous concentration. A few of these principles are currently under review. Reference is made to the Ajax Unified Requirement URH1, so in the incoming months, NR 671 will be amended accordingly. We said already that the risk assessment is crucial, is to be carried out. Zero leakage philosophy is applicable, so double wall including an open deck, ammonia vapor treatment system, dedicated drainage tank to manage liquid leakage, low concentration detection and control of ammonia discharge at sea. The materials compatibility is a challenge. Ammonia is corrosive, so the choice of the material for the storage tank is a concern. Storage requirement depends on the technology. It can be type A or type C. And other general requirements are prevention of flammable or explosive atmosphere, limitation of ignition source. Zoom on ongoing work at time with the latest outcome of CCC9. Dedicated working group is to be held next September 2024 and then finalized during the CCC10. Interim guideline for the safety of the ships using ammonia as fuel is to be approved at MSC 109 in December 2024. It has been agreed to stay in line with the EGF code as far as possible. Vapor concentration limit to be agreed on. Full holistic risk assessment should be performed. ESD principle related to the use of single wall piping will be not considered for the guidelines of the default option, having a gas-free arrangement. Bunkering station should be located on open deck. Closed or semi-enclosed station should be considered in the risk assessment. High manganese austenitic steel are considered resistant to ammonia stress corrosion cracking, and therefore it can be used for ammonia as cargo and fuel tanks containing ammonia. The full decarbonization of the shipping before 2050 is an IMO ambitious goal. the challenge cannot be addressed alone by renewal of the fleet with the new technology ships. Part of the worldwide fleet is still young. It's not possible to believe that they will be replaced shortly with the vessel adopting a new technology. So the ship owner will have the necessity and the possibility to retrofit the existing fleet. Here an example of ammonia retrofit for LNG ammonia in a container vessel. We can see that the cargo hold forward the engine room has been converted in spaces for the dedicated storage tank, and all the other compartments which are needed to the handling system of the gas. From design point of view, the amount of the study is quite extensive. In this case, for example, we are carry out before retrofit and after retrofit a torsional analysis, and we can see that in the cargo hold near to the one dedicated to the storage tank, there is an increase of deformation. Increase of the stress. Other involvement of BV for ammonia are on VLGC and LPG carriers, approval in principle, so they are not yet at the definitive design stage. So approval in principle of ammonia carrier in different shipyards, memorandum of understanding for ammonia bunkering vessel, and approval in principle, for example, for LNG ammonia tanker with gas in it. And of course, HAZOP for study for ammonia fuel, and approval in principle of a different system dedicated, focused on ammonia fuel, and of course a discussion with the main engine maker in connection with the approval of the engine. So the technology is there. Of course, as we already discussed before for methanol, the problem of the infrastructure exists, but the risk assessment can be done, the technology exists, so the approach is quite ready to have a vessel fueled by ammonia. Of course, on board the passenger vessel and the yacht, it can be a big challenge.
Thank you. I already have plenty of questions, but before we get to that stage, if you'd like to please take a seat. So we're going to have a few panelists joining Antonio to discuss, in fact, from that presentation, which is more about the technical aspects and the regulations, and we can see how it applies to the shipping side of things. How could that be turned into reality within the yachting industry? And to that purpose, I'm calling to the stage Emmanuel Guillouard, Business Development Director at SBM Offshore, Lex Nyssen, and you'll correct me if I pronounce your name. Yeah, it was good? Okay, thank you. Head of Marine Region, Europe and the Americas for MAN, and you're making my life difficult here. I don't know how you say Akon Skerstad, if he's around. Or maybe I pronounced his name so badly. Yeah, it was good. Okay, thank you. Who's the CEO of Azan Fuel Solutions, and of course Antonio, who's already on stage. Emmanuel being the first to join us on stage, I'll give you the clicker if you've got a few slides to go through. Please welcome these gentlemen who are going to try and convince us about ammonia.
Hello. So we've been looking at a sister industry to yachting, that is shipping. Shipping is important in terms of emissions. It represents nearly 3% of all global emissions. And the objectives of IMO are to bring shipping to net zero in 2050, even though that's going to be challenging, and to reduce emissions by 40% in 2030. Interestingly, with only 5 to 10% use of alternative fuels, the other ones being, let's say, already available solutions. There are numerous fuels competing for the future. We mentioned about methanol, ammonia, hydrogen, and it's very difficult to say who's going to win in the end. And I always make a joke about that. I say, if I knew the future, I would be extremely rich. What we can see is that methanol, being a carbonated molecule, it's not going to be possible to achieve net zero with methanol other than by accounting magic called offset. Having said that, this is a very good molecule for transition because it's technically an achievable solution. Ammonia is a step behind. It's NH3, so no carbon in the molecule. So when you burn it, there is zero carbon emission. There are NOxes, nitrogen oxides, right? Yes. But this is no different from the diesel emission, the emissions you have on a diesel car that are captured with AdBlue. So the solutions to capture the NOxes are readily available from a technological standpoint and are reasonably inexpensive. Ammonia creates a whole set of new challenges. It's a toxic molecule. It's got a reasonably low energy density compared to marine fuel oil. But it's zero carbon emission. One more thing with ammonia is that about 200 million tons of ammonia are produced around the world every year. It's the second largest chemical in use. 20 million tons of ammonia are being traded intercontinent today, meaning that you've got trading facilities, spot markets, logistic facilities to store, offload and ship, and this may facilitate the adoption of ammonia as a marine fuel in the future because as it was mentioned in the earlier panel, logistics and availability of supply is quite key to adoption. After ammonia, there is the nice ambition of hydrogen, and hydrogen is again a further step behind. It's a very, very difficult molecule. Hydrogen is the smallest molecule that does exist. So it makes it very elusive. Hydrogen can navigate through the steel structure, the structure of most molecular steel. Okay? And when it navigates through, it produces what is called hydrogen-induced cracks, which makes the steel permeable. Hydrogen then can evade into the atmosphere, and mixed with air, it becomes explosive at a ceiling of 4%, which is extremely low.
Emmanuel, we're not going to talk about hydrogen on this panel. Also because, just as a reminder, in case you didn't know, we've got the hydrogen working group roundtable tomorrow morning. So if you're not registered for it yet, you can also join tomorrow. Hydrogen will be the topic of tomorrow. Thank you.
So what we said is that we have 3 alternative fuels taking the panel. The key criteria for the choice of fuel will be compliance with international regulations, fuel affordability, price matters, especially in the shipping industry, technology readiness and the associated risk, safety is a big one, fuel density versus ship autonomy, short haul applications do not drive to the same choice as very long haul applications when you need to do intercontinental travel, and the availability of supply chain readiness and bunkering facility, fuel availability at ports. Maybe.
Thank you. Yeah, thank you, Emmanuel. So Lex, tell us what you think. You've got the mic, and you've got the clicker. Is it on? That's not yours. That's still Emmanuel's. Carry on. Oh, there we go.
Is it working now? No, it's not working. Thank you for that. So, yeah, ammonia for two-stroke engines. We as a company, as MAN Energy Solutions, we provide, we have a slogan, and we say we move big things to zero. So we try to help all our clients with a lot of products to go to decarbonization. Besides providing carbon capturing and heat pumps, etc., we are also in the engine business. And in the marine engine business, we have now the big challenges in developing also engines for ammonia as a fuel. I just want to show you a little bit where we are on the stages of development now. So we have an engine, a two-stroke engine based in our research and development center in Copenhagen. The engine is running there on, it's a 4-cylinder engine, so we started first with 1 cylinder and then we added all the 4 cylinders now running on ammonia as the fuel. The first engine is now being built for commercial practice, or actually for field testing practice. It's under construction and will be delivered later on this year to a shipyard in Japan for a Japanese customer. And then we will first, when the ship is launched, we will have, of course, a lot of also our research and development people on board, because we want to gain a lot of field experience. This is such a new technology, and as we have also seen from the colleague from Bureau Veritas, that there are quite some challenges that we have to tackle with regarding to safety, and for us as well, the emissions, that we have the emissions under control. If we run the engine too rich or too lean, that means that we are producing much more greenhouse gases as what we try to avoid by reducing the CO2 emissions. And that's quite a big challenge. So the combustion is our main topic to tackle that. At the moment, it's running fine. The engine is, as I said, it is running in a test bed. It's one of the big benefits is that we have already achieved is the engine is running instead of, we were expecting about 15% pilot fuel that we needed to keep the ammonia burning, because ammonia is not really a self-burning fuel and it's very slow burning, but we are already at the 5% pilot fuel level, and we hope to decrease it even more, but at the 5% is already a big achievement in our perspective. So what are we going to do? Then the engine will be delivered later on this year, as I said. The ship will be launched and coming into service in the beginning of 2025. And then we will see, okay, 2026, 27, we will have some good enough experience to get a full sales release after 26, I would expect. This is a little bit different approach as that we normally do. We have normally a much earlier sales release already because we know that the product will be running. But this is too critical. We see that if something goes wrong, then we can still step in and then we say maybe it's technically not possible, which is not seen so far. Engine releases for the different engine types, which are mentioned here on the screen. So that means engines between 9,000 and 40,000 kilowatt, something like that. So it's not yet for yachting purposes, but it's at least to see from an engine manufacturer perspective where we are at the moment with the development of engines running on ammonia. Thank you.
Thank you.
You've got slides as well? You've got the clicker. Okay, good.
Good morning, everyone, and thank you to the Yacht Club for inviting me. Ascent Fuel Solutions is a company that develops and delivers solutions for handling ammonia as a fuel. And that's basically two things. Bunkering solutions for all kinds of bunkering applications, and onboard technology that you need on board the vessel itself to receive the fuel, to store the fuel, to refrigerate the fuel, and to deliver it into the engine at the right pressure and right temperature. So we are a company that is owned now by Navigator Gas, which is one of the biggest transporter of ammonia. Yara Growth Venture, which is part of Yara, which is one of the biggest producer of ammonia, And we have 2 Norwegian startups as owners as well. And what I would like to kind of address to you today is the fact that ammonia has, up until to this year, been perceived as a future fuel. That is something that we will see maybe in 2030, maybe 2035. But the fact is that 2024 is probably going to be the breakthrough year for ammonia. And there's a couple of things underlying that statement. First of all, the Norwegian government has been putting a lot of money into ammonia-powered vessels. So they've run the tender recently, and they're running another tender over the summer. In addition to that, they're also giving a lot of subsidies to ammonia infrastructure, that is ammonia bunkering. So our expectation now is, in the wake of a third tender that is being run by Equinor, which is the biggest Norwegian oil company, we will have an investment decision on the first bunkering terminal in the world already this year. That means that in about 2 years' time, we will have the first commercial bunkering operation on the Norwegian coasts. As you see on the picture here, it's not the biggest sizes vessels. These are, and there's a very good reason for that. There's the vessels that you see here are platform supply vessels that go out to the oil platform on the Norwegian continental shelf. They go back to the supply base and back and forth. And that's ideal for establishing a network for ammonia bunkering. The second thing that we are working on now, we are already now working on tomorrow, because we know that for decarbonizing the big ship segments like the container vessels, for instance, we need bigger solutions. And we have over the winter now developed a concept, a bunker vessel, in order to demonstrate that the solution that we have developed for the Norwegian terminals are scalable. We now have a bunker vessel that is ready to be further commercialized. So we're looking for commercial partners in ports of Singapore, Rotterdam, Antwerp, and all the biggest ports, where we hope to be able to be in a position to soon have an investment decision on the bunker vessel as well. The thing that is missing now, and the reason why we don't see more of these projects now, is the economics of the ammonia compared to traditional fuel. Compared to all other alternative fuels, ammonia is probably the cheapest alternative. But the problem is to have the right incentive both on the CAPEX side, but also on the OPEX side. Once that gains traction, we will see benefits of scale in the production of ammonia, green ammonia. We will see benefits of scale in the infrastructure that we are developing and delivering. And we will also see improvements when it comes to technology, safety standards, etc. And with that, I'll give the word back to you. Thank you.
Thank you. Thank you. Lots of questions for all of you. The first one, it's interesting what you said about CAPEX and OPEX, because I guess this is something that's an issue for most of the developers of alternative solutions, the fact that we need to have incentivizations from the governments to help on the CAPEX, but also on the OPEX, which is often missing. First question for all of you, really. I mean, honestly, Antonio, you didn't give us a very good feel about it in terms of highlighting all the challenges, right? So my first question is, okay, well, to what extent you see ammonia as an alternative that is of interest to the yachting side? Obviously, the methanol panel was very good at showcasing how methanol is moving forward and seemingly ahead in when it comes to technology regulations and everything compared with ammonia. But do you see beyond big ships the relevance of ammonia, or how do you see it for yachts, basically? And what kind of size you can imagine?
First answer from me, not for this decade. There are still quite a lot of challenges, as I said, and I mean, one of the biggest challenges that we see is the toxicity. To have an engine like that, or the fuel like that on board of a ship where quite a lot of passengers can be on board, that will be a challenge. So I think it's first in the industry on bigger ships with only a few people on board, there where we will develop the technology, get experience with the safety concepts, etc., before it might come to smaller scales.
It's more likely to be 2050 and beyond than 2030 or 35.
That's how I see it, yes.
Yes, the expectation for ammonia to be widely used in shipping is starting from 2035. Then you could plan for 5 to 10 years before the technology becomes mature, the fuel available, and it can go into the yachting.
I think coming to the question whether we can do this safely for yachting, absolutely. It's perfectly doable, technically and safety-wise. Is it going to happen in yachting? I'm not sure. I'm not sure if it's going to happen in the 2030s. So, and that's not a safety issue. That's, for me, that's a perception. And I think the users of the yachts will have certain concern, regardless of how safety is. Why should the yachting industry care about ammonia? I think when you look at the numbers on the different alternative fuels and the availability of those fuels for the different ship segments, I think the yachting industry will benefit massively from having ammonia available to the bigger ship segments, so that they don't compete on the alternatives like methanol and biodiesels, for instance.
So basically for the larger units, like really the big ones. But then what about the fact that you've got to bunker on deck? I don't know if you noticed that, but one of the points that Antonio made was the fact that you need to have your bunkering, your fuel is actually in open air. And do you see that? Because when you look at the yachts out there, that's not really something that yacht owners would find relevant, even on big ones. Is that something that can be addressed, or there's really no other options but to have bunkering on deck?
Well, you can do a risk assessment where you have not enclosed open space, but enclosed space. So you have to make mitigating action. You have to probably add means to measure the possibility of leakage. It will become a little bit more difficult, but the risk assessment is for that, to mitigate all the possible risk and incident. The social acceptance is important for ammonia. Of course, the passenger on board will be not authorized to go and touch something, so this is for sure. But an incident on board the cargo vessel, he will have an impact on 23, 24 people. An incident on a passenger vessel or on a yacht, maybe there are more people, and this is for sure to be taken into consideration. But the technology is there, and the risk assessment is fit for that. So in the future, why not?
The three of you want to comment, so we'll do it in that order. Okay, please.
Yeah, another aspect is refueling, bunkering, or ammonia loading, offloading at a distance from human activities. And in that respect, SBM Offshore has developed a range of CAN buoys terminals, so that this activity can be taken offshore instead of in harbor.
Something which is not allowed for other alternative fuels, like you can't do offshore bunkering for methanol, or you can or you can't. Can you do it for hydrogen? Obviously not at the moment either, but so you think that ammonia offshore bunkering is a way forward as well?
Yeah, and I would like to add an example from the development on the platform supply vessels that I mentioned earlier. In that case, the class society worked together with the ship owner, and they were told that certain solution or a placement of the venting solution on the vessel was not compliant. Then the ship owner ran several quantitative risk assessments and disbursement studies to show that, which showed that the solution that they had chosen was much safer. And the end result there was that the class society said, okay, we see that the facts are telling something different from our guidelines, so we will accept the solution. And I think that example gives kind of the idea of where we are at the safety protocols today. Those need to be developed, and we will see the safety standard today for ammonia will be something different in the next years to come.
Thank you, Alex. And then we'll have questions from the audience.
This one is working. One of the other aspects at the moment is also the fuel equipment itself. That is quite spacious, and we heard the previous speakers about the methanol that's already taking so much space on board of a yacht, and we expect also for the ammonia that is quite spacious, especially how to handle the return fuel, so the fuel that is not burned by the engine but coming back into the system, how to handle that. Partly it's gaseous, partly it's liquid, and to get it back into your bunker tank or in your day tank, etc. That's taking quite some space, that equipment.
Thank you. Thank you, gentlemen. One or two questions from the audience.
Good morning, I'm a member of the Yacht Club of Monaco. Thank you very much for your presentations. I've been in the bunkering industry for many years, and I have a double question which applies both to methanol and to ammonia. First of all, have there been any assessments of the diminishment of pollution if we look at the global process from the production of methanol and ammonia all the way up to the consumption? What is the difference in pollution between those two products and heavy fuel or diesel oil? This is my first question. And the second one is, were methanol or ammonia being used on a global base heavily by the shipping commercial industry? Would we have enough ammonia and methanol? And what stress would it put on the other sides of the economy which use those two products? Thank you.
I'll be careful to answer on the methanol side, but for ammonia, there's a study done recently now. I don't remember if that's DNV, but one of the class society, I think, which shows the entire value chain from the production to the wake, and they've shown that there's a significant potential for decarbonization, and it's going to make a massive difference. If you go over to those fuels compared to the traditional fuels. So I'll share the study with you so you can go into the details. The second point which regarded the volumes available, I think that's going back to my point earlier. There is some concern on methanol and all the alternative fuels that have carbon, because you need a carbon a green carbon that you can recycle into the loop, which is tricky, but there will be a significant amount for that, but not the same amount that you will have for ammonia. Ammonia has now, there's an annual production of around 200 million tons of ammonia today. There's planned around 200 million tons of production capacity, blue and green ammonia, before 2030, so we will see a doubling or potential doubling of the ammonia production until 2030. Maybe 50% of those projects go through, maybe 25%, but the fact is that for shipping, you might in 2030 you might only need 40, 50 million tons. So there's plenty of supply. I'm more concerned about the demand side. We need demand aggregation to really get the traction on the whole value chain. Thank you.
Thank you. Any other comments for the other panelists on these questions? Well, thank you, gentlemen. The good news is that you're going to have a break. We've got about 20 minutes coffee break, which will allow you to carry on the conversation and further discuss, especially your questions about the methanol panelists. So you can talk with them while having a coffee and a drink. We're pretty good on time, which is rather surprising, but we'd like to keep it that way. So if you can please return to your seats by 11 a.m., then we can crack on. And we've got another 3 panels with quite interesting topics to tackle, such as nuclear for yachting and artificial intelligence. So you'll see that, the future looks promising. But that's for after the coffee break. Thank you.
Thank you very much. Nice to meet you. Christina, the lecturer. Thank you very much. Bye.
To get away, getting fed up with the day-to-day. Leaving 10:35 like Tate McRae. Been a robber on a sun-soaked highway all of my life. I've been chasing that high. Let's unplug and let's rewind. It's just you and me tonight. From the hotel bar to the Hollywood stars, driving around in a rental car. Nobody knows who we are. From the sunset skies to bright blue eyes, la vida loca for the rest of our lives. Nobody knows who we are. We're living like rock stars. Yeah, we're living like rock stars. We're living like rock stars. Yeah, we're living like rock stars. Looking for that old town road while walking on streets that are paved with gold. Going down to Venice Beach, we ride the wave, yeah, it feels like we made it. All my life, I've been chasing that high. Let's unplug and let's rewind. It's just you and me tonight. From the hotel bar to the Hollywood stars, driving around in a rental car. Nobody knows who we are. From the sunset skies to bright blue eyes, la vida loca for the rest of our lives. From the sea on the road to a home. Go, 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 go. Yes, go, 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 go. I follow you. Go, 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 go. Yes, go, 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 go. I follow you.
As fast as I can to break the walls in my head. Try not to lose myself, but let it go instead. And I'm up all night long, can get no sleep at all. I'm tired of spinning all around my memories. No, would be time to move on, but I'm still holding on. I'm thinking about you, dreaming about you. I'm thinking about you. I'm dreaming about you. I didn't know where I would stand. Bury my head in the sand. I need to choose myself and leave behind my past. I've been waiting too long, now I won't take the call. I'm tired of always losing my energy is low. Don't know what's going on, I'm trying to stay strong, not to think about you, dreaming about you. No, I'm thinking about you. Tell me why we don't go to find a place that we call our home. Oh, watching the waves and sunsets laying down in the sand. So please tell me why we don't go. is how you get me. So please don't go away, 'cause I need you to stay with me. Will you stay with me? Yeah. Watching the waves and sunsets laying down in the sand. So please tell me why we don't go. Drifting away like wave after wave, deep into paradise, breaking the faith, sinking in motion, miles away, wave after wave. Wave after wave.
Pineapple fields. Yellow and green, such a beautiful scene. Taking me deep, where the wild never sleeps. Fireflies under open skies. I hear the nature call, carrying me from low to high. The colors light up the dark pineapple fields. Pineapple fields. Came from the rain when the city was pale. 6,000 miles, no sun, no way smiles. Fireflies under open skies. I hear the nature call, carrying me from low to high. The colors light up the dark pineapple fields. Pineapple fields. Pineapple fields. Pineapple fields.
Take a chance on something strange. There's a world on the other side. Maybe I'm afraid to change. Don't give up, just give in. See yourself in different light. Pull me out from deep within. Stay close to me, hold me tight. Is there anything that I need to know? If I let go, will it leave me blind? Would you help me see? Or maybe you are all that I need. Show me how to love right. Tell me you are all that I need. And tell me what it feels like. Just tell me what it feels like. Hold my breath as I dive in. Surrender to the other side. Even I can start again. make it daylight. You got your way, I won't debate that. I'll make it daylight. You got your way, I won't debate that. I'll make it daylight. I'll make it daylight. You got your way, I won't debate that. I'll make it daylight. You got your way, I won't debate that. I'll make it daylight. I'll make it daylight. Fingers on my chest, right here next to mine. Memories we kept, never blinked an eye. Now we're falling again, without thinking twice. We can make all of the same mistakes. Do you and do I really just need somebody? I need somebody. I really just need somebody. I need somebody. Do we just need somebody? 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 Do
Test. Hello again. I know that outside you probably can't hear me. So if anyone inside would like to help and bring the people from outside back in, so that everyone can return to their seats as soon as possible. It's already 11 a.m. So please kindly return to your seats so we can proceed with the next panels. For the people outside, if you can hear me, please kindly return to your seats. We're going to get started again in about 2 minutes. I can see there's a nice move back inside. So the same principles apply. Please kindly keep your phone on silent. And when given the opportunity to ask questions, as I'm sure there will be quite a few for the next sessions, make them short. So in order to save a bit on time, I'd like to call on stage Nathalie Kever, who is project manager for Sea Index, Holly Taylor, who is associate director at Marine Shift, and Giuseppe Sagaria, who is back as a marine technical director from Marina. And they'll be giving us a brief overview of the fact that a topic that was in fact mentioned through one of the questions about life cycle assessment and the importance of not only considering carbon emissions in use, in a way, but throughout the whole life cycle of a yacht, from construction, obviously, all the way to dismantling. So a brief overview by our three panelists. I don't know who's going to want to talk first. I assume Nathalie will be the one.
Really?
You've got a clicker if you've got a presentation. Is your mic on or not?
Yes, it is. Thank you.
Yeah? It's on? Okay, fine.
I only had one slide. There you go.
All right. Is everyone back? For the last people who are still having a coffee, if they could... yeah, I'm going to ring the bell, I guess, yeah. I've always dreamt of doing that, right? Okay, we give you another 20 seconds to get to your seats. And then, Nathalie, the floor is yours.
Thank you very much, Laurent. Good morning, everybody. Thank you very much for inviting me to speak on this particular conference. We wanted to just probably give you an update of what's happening with the Sea Index. We've had quite a lot of development recently. During the Monaco Grand Prix, we were very pleased to receive Cap Energy's label, which was very important for us because it's a label that is very well respected in the energy sector. It normally accompanies innovations who are seeking to receive funds, which was not our case, but they saw the value of what the Sea Index was trying to achieve. And although they didn't know the maritime sector in detail, they saw the value of trying to calculate and measure CO2 emissions based on propulsion and life on board of superyachts. So that was one of the big milestones at the middle of this year. And we feel now that we've achieved a level where we're actually getting somewhere. So the C index, just as a reminder, was created as an emanation of the Yacht Club de Monaco. Historically, it was co-founded with Credit Suisse. And our initiative being an association and also creating a tool to calculate or to measure the carbon intensity of super yachts was dedicated and is still dedicated principally, mainly for super yacht owners. Super yacht owners, members of the club, but also super yacht owners outside the club who just want to get a snapshot of where their yacht currently stands. It was very important for us to have this certification third-party verified, which we do with Lloyd's Register in the room, who we carry on to work with. And what's actually happened recently is that we have received favorable reputation and favorable words for what we're trying to do. And recently, about 10 days ago, we calculated that we're actually deploying the C index to 12 ports. And a few days ago, it went up to 15. Now we're at 16 ports who have agreed to deploy the C index across the Mediterranean facade or the coastline, going from Bonifacio to Menton to Saint-Tropez. So for us, this is a very big milestone. It's quite scary because now the individual contracts have been signed, but now all the work remains to be done. What we're trying to do is to create a collective, a community of C-index certified yachts and C-index members of the association, so that these boats can benefit from certain incentives. Here in our marina at the Yacht Club, the C-index boats that receive favorable rating as of 3 stars, they can get discounts in our marina. We have also received further news that these discounts, certainly in terms of the SEPM here in Monaco, they voted unanimously on the 20th of June to apply the same discounts in their ports. So that means Port Hercule, Fontvieille, and Cala del Forte and Ventimiglia. So that is very, very good news. We have members of the C index who receive favorable ratings, and unfortunately they weren't able to fit in our marina because our marina is 66 meters LOA, but they are next door, and so this is just a little incentive. The point is not the discounts. The point is that we're creating really a movement of super yacht owners who are more akin to seeing the impact and to calculating the impact and making educated choices. Our only mission is to support them in that endeavor. But today we have another announcement. So news is going fast. Today we have another announcement with my colleague here, well, my friend now, Giuseppe from RINA, because again, still in this endeavor to create a network with all stakeholders, because obviously we're representing super yacht owners and members of the Yacht Club, but also stakeholders including all class societies. With RINA today, and Giuseppe will be able to tell, we are launching a new methodology to calculate the operational side and the emissions impact based on consumption of fuel, well-to-wake approach, can take into consideration biofuels with different concentrations. And again, it will not be certifiable, but it will be a tool that super yacht owners can use, and perhaps super yacht owners that maybe didn't get a too favorable C-index certification based on the design of the yacht, but they can still make a difference on the choice of fuels that they use. So voila, that's what we're doing, and we're carrying on, and we thank everybody. There's a lot of people in this room who've supported us from the beginning. A lot of people that we will be working with in the future, people that we are signing contracts with at the moment, and we thank you very much, because it's thanks to you that we can provide super yacht owners with the means and the information. We pride ourselves in the fact that our information is neutral, because we're a yacht club, we're not selling anything, and we thank you very much for that investment in time and support that you're giving us. Thank you.
Thank you, Natalie. Before Ollie gives us a bit more details about the life cycle assessment and how you work on the C-index, and Giuseppe tells us about the RENA, I have one question for you. You mentioned incentives, the fact that if you're recognized by C-index and have a good rating, you can benefit from discounts. Is that something that is in fact very appealing to yacht owners? I mean, what's been the initial reaction, perception? Can you see that they're looking at changing their approach and improving their own just based on the fact that they've got incentives?
It actually has. It actually has. I think that one of the main challenges when you're trying to shift the dial in sustainability is to try and change. We talked about perception, about ammonia, and later on I'm sure we'll talk about perception regarding nuclear. It's the same for sustainability. It's to try and change people's perception. And if you can draw their attention to, you will get a discount if you do this, that, and the next thing. They're not doing it for the money, but it's a little help, and it has really made a difference. Now, it has to be said that for ports that we've signed with along the coast, many of them are owned by public. They're in the public domain, so of course they cannot give discounts. It's normal. It's taxpayers' money. But what they are doing, and some of them want to do this, moving along, is to give preferential, for example, in busy seasons, a yacht who's actually gone through the C-index certification arrives in a port, and for boats that arrive, 2 boats that arrive at equal size, these ports will give preferential, they will give the berth to the boat who's done the exercise. Now, some of them, it's not going to be from the 3 stars that we apply. Everybody is free to apply what they want. We're not pointing any fingers. We're not telling people to do this, that, or the next thing. But they might just do it. You've done the exercise. Okay, you didn't get a good rating, but you did the exercise. And already that makes a difference. But yes, it does work. It's human psychology. We all like to be rewarded for something. We all like to be shown that we're doing something better. We don't like to be told, you're bad, you're doing this. It doesn't work. It doesn't work. We're all like that. It's not particular to super yacht owners, I would say.
Thank you. Who wants to speak next? Ollie?
Yeah, it looks like it's me. So yeah, thank you everyone for coming this morning. I run a project called Marine Shift 360. So Marine Shift is a joint venture between 11th Hour Racing, who are an ocean conservation charity, and Anthesis Group, who are one of the largest pure play sustainability consultancies globally. And we exist for kind of one real simple reason. It's to give the industry the tools to work out the impact of what they're doing today and what they're likely to do tomorrow. So using the discipline of life cycle assessment, we're working with the shipbuilders, yacht builders, boat builders, the supply chain, to really help them calculate the data that drives decision making to ultimately reduce. I think we've already heard this morning there's a myriad of options in front of us to decarbonize this industry, from hydrogen, methanol, ethanol, ammonia. Ultimately, not all of these solutions are made equal. Lots of them will play a role in this transition to a low carbon future. But what we're interested in is quantifying what that reduction value is and enabling then the boat builders to work it out for themselves and have the tools to do this on an ongoing basis. Very quickly, how does that process actually work? How do we do that? So fundamentally within life cycle assessment, you're trying to understand the impact across the entire life cycle. So from the very original raw material extraction for the materials, all the way through to the end of life solution. What do you do with the vessel at the end of the process? Where we're slightly different maybe from some of the others in this space is we do have quite a heavy focus on the production phase of a yacht. Our specialist area has been predominantly in sub 30 meters, where the operational profiles are quite different to a super yacht, where we've seen in a lot of the studies the emissions sit quite heavily often in the production phase rather than the use phase. Very different for super yachts, I appreciate. But essentially what we're allowing users to do is model that bill of materials, all of the raw materials that go into a yacht, converting those materials, and then including the use phase, the fuel you use, the energy, into environmental impacts. And we go further than just carbon as well. Carbon is very popular, everyone talks about it, it's a very important metric, but we also look at an additional 6 impact categories, which give a more holistic view of how sustainable a product, system, service is. That generally then gets converted into this impact dashboard, where you can visualize where are the hotspot areas in a project. And LCA often is a very nebulous subject. People think it's quite inaccessible, it's quite hard to use. The truth is, within LCA, there's different levels for how deep you want to go. So a lot of the users we're working with are doing something called a screening assessment, where you kind of have a very rough assumption of the bill of materials, the use phase, and you fire it into the tool and it will quickly show you where you should actually focus your energy in finding decarbonisation options. And again, in more of the production yacht sector, the sub 24 meters, lots of people have possibly focused in the wrong areas to date, but they're now very quickly realising actually there's different focus areas. Understanding what your baseline is one step in the journey, but ultimately where the value creation comes from LCA is simulating the variables in a production system. So working out, if we change from our diesel engine to a hydrogen fuel cell system, what reduction do I actually realise? Is that enough? Or actually, if I'm going to ammonia, maybe that gives me a different outcome, or a battery system. So fundamentally what we're doing is giving the industry the tools to work this out for themselves and hopefully work collectively to reduce our impact.
Thank you. I've got a very big question for you. And since you're considering the entire chain, from construction, obviously, to propulsion, use of energy on board and beyond, from the studies that you've made so far, I mean, we obviously talk a lot about propulsion and energy on board, whether it's for hotel load or propulsion. But can you have an assessment of the reality of the environmental impact of yachts on the various stages? And is propulsion, in a way, the most significant one? Where does that stand from the analysis that you've conducted?
Yeah, the answer is it's unique to every vessel and every subsector within this industry. So super yachts, I think often you'll see higher impact coming in your hotel load, for instance, rather than your propulsion because of the way a vessel's used. If you're talking more in the sub 24 meter category, we very frequently will see a 50-50 split between production phase impact and use phase impact. So just changing your propulsion system will not necessarily solve the total life cycle impact of that vessel. But yeah, ultimately it really does vary by the type of product you're looking at.
So you're saying 50% for sub 24 meter, 50-50. And when it comes to the 24 to, let's say, 60 or 70 meters, what's the ratio between like the production, environmental impact, and the use?
Yeah, I'd say the use is generally you're moving much more towards like an 80-20 bias, possibly more depending on the time frame that you're studying across as well. You know, is it a 10, 20, 50-year lifespan that you're looking at? Do you include the refit process as well within that yacht, where there might be a re-engineering, new generators, new systems on board? But yeah, typically the larger the boat, the longer it's lasting, and the more bias you will see to impact being in the use phase.
Thank you. Giuseppe, can you tell us about how RENA is going to be pushing for the adoption of sea index methodology, especially in Italy, where all the big yachts are built? Well, not all, but many big yachts are built.
You know, if you see any kind of reports, especially there is a study by the International Energy Association, they project from now to 2050 which one are the single efforts that will contribute to reach the net zero. Still improvement, okay, about how the ships is managed, how the ship is used will contribute a lot. In the shipping, finally, we start to see some changes because the ship design criteria is not only based on what the market wants, but on how the vessel will really be used. So how much really is the speed that I need, how much is the energy consumption that I'm going to need. I will be very, very quick. So we think from the operational point of view, it will be more and more common to have inside the design priority some elements from the operational part of the yacht. This will have some influence about how much is the fuel capacity and how much is the real energy production amount or propulsion power that I need. This is possible for yachting more than to shipping, especially due to the very peculiar operational profile that has a yachting. Okay, the yachting basically is like to have three vessels in a single boat, 3 souls in a single boat. So the different technical solution together with an improved operation will have a lot of benefit for yachting, even more than for shipping. Then we realized that when we speak about efficiency, we should consider also the quality of the energy that you bring on board. When we say quality, we are speaking about how much which one is the source of this energy that supposed to be sustainable, but on the other side also how this energy can be combined with other energy source. We don't have to forget we are in a transition period, so it is impossible to do a single step because the stairs is too long, so we have to do slowly. Finally, when we speak about operation, we don't have to forget the importance of the data management. There is, as you know, a very famous saying to say that only what can be measured can be managed and can be improved. So it is extremely important to have a mindset, okay, following data collection, but also to capitalize on data. So which data is really important, which data I need to make a choice that, improve my yacht and improve also my pocket at the end of the year. And finally, the item of sustainability, actually it is linked to the bullet number 3, because we believe to choose the right fuel means also to choose a sustainable fuel. Okay, finally, I take the chance to say something more about our cooperation with the Syndex. We started this cooperation basically 1 year ago. It has been a very interesting journey, Natalie, for what she has done. The tools that we developed, the assessment method that we developed, it is completely future-proof. So basically, we and Natalie, we sit and we think, let's put the clock ahead 5 or 10 years. Let's try to imagine how we can help the yachting industry, how we can help the cluster here in Monaco about an assessment method that is completely future-proof and well-to-wake. The tools take into account how much is the real emission by the yacht, not just what potentially are the emissions based on design, but moreover, you take into account the quality of the fuel, and last but not least, you consider also the blending of different fuel, because as we said, we don't think you can reach the net zero in a single step, but we will do considering a mix of solution. When we say mix, we also consider a blending of different fuel. I'm very pleased to say that we will deliver these tools to Syndex. We work it together, and you will find it available on Syndex website, because we believe sustainability means also to be transparent. So thank you very much.
Thank you. A couple of questions for you. Of course, for you, it's always challenging questions.
Thank you so much.
As Natalie said, obviously a lot of the efforts and the development of the Syndex has to do with yacht owners willing to take that step, making the exercise. To a certain extent, shipping is under a lot of regulations to be able to make their assessments, have the data collected, they have to submit data. But there's no such thing in yachting yet, right? So first question is, do you see that changing, like at some point, and when can the shipyards here when they work on the designs of new boats, need to take into consideration, and yacht owners, the fact that they're going to be also scrutinized for their sustainability impact, if that is ever to be the case? So that's the first question. And then I'll give you the second one.
I hope I'm not too optimistic, but I think good things, good behavior are generally contagious. So if we start to stimulate the yachting in a proper way, and I agree with Nathalie's perspective, to give some little rewards, everybody are happy, to change their attitude towards a reduction, especially of emission. So I'm pretty confident that step by step, time by time, we also are having some seminar with some masters association, and there is extremely very positive, willing to improve on that one. So at the end, we are changing habits and behavior that has been with us decades. So we need some time, but I do hope also shipyards will benefit from this new attitude.
Thank you. Well, obviously some shipyards that attended the sessions earlier are very proactive, and I would be a bit optimistic by seeing most shipyards are being proactive nowadays. When it comes to the Sea Index and RENA's involvement and the certification, in a way, we say, okay, you don't have to do it, right? But to what extent, when you speak to shipyards or to naval architects, these suggestions, these pieces of advice into how they could do it better, is that something that RENA is already doing and obviously pushing through, and how is it received by the shipyards and the yacht owners? Because Sea Index, we talk about measuring emissions, carbon emissions, different sources and types of fuels, but we know, as Oli also said, especially on the smaller segment, obviously, 50% of it is linked to the construction. So changing the way yachts are built right from the start is obviously makes a big difference. So when you have these conversations with the shipyards and with the yacht owners, how is it moving forward? How proactive are they? Nathalie, or?
I answer that just because it's prompting some things from my side. The Sea Index, as I said, was created first of all as an answer, a call to action from discussions in the Yacht Club to support the owners. And it was always, in our heads anyway, it was always going to be about the existing fleet. But now what's happening is we're actually working with shipyards on their different projects because they want to integrate the Sea Index from the start. So that's an involvement again, and more things that have been happening this year, and which also started the year before. And now they really want to implement. As anything, you start with a discussion. You sniff around. Is this thing worthy? And then now we're actually in talks with two very, very big different shipyards because they want to do things from the start. So this is new for us as well.
Even on the smaller segments, because there's a lot of yacht and boat builders, obviously, in the smaller segment, less than 24 meter.
Yep.
And they're becoming more proactive about it.
Yep, exactly, with the smaller segment. And again, to say that everything is linked, these conversations, so because the Sea Index to begin with, we can rate yachts from 25 meters and above. We have members here in the club are saying, well, my yacht is 18 meters. How can you help me find out what my impact is? So that's how these discussions start with class societies. Okay, how can we help these people? But yes, to answer your question, we're in discussions also with shipyards for the lower segment.
Ali, one last comment before a couple of questions from the floor.
I think it's just to answer the legislation piece. I don't believe we will see any very marine-specific legislation come in that forces us to reduce emissions. Where legislation is impacting the industry, though, is the wider kind of EU green policy. So things like the Corporate Sustainability Reporting Directive, where lots of the larger shipyards within Europe are going to have to start disclosing what their impact is across scope 1, 2 and 3. So it's going to become public information how impactful these businesses and these yachts are. The other angle is then within the supply chain of the yacht builders. So things like the Carbon Border Adjustment Mechanism, CBAM, where there is going to be higher taxation on certain raw materials. The more impacting the material, the higher the cost will become. So you will see the cost go up to maintain business as usual with the materials we use. So the incentive will drive people to look at alternative propulsion systems, alternative hull structures. And then the final bit of legislation, and legislation is quite boring to talk about, but is the ESPR, European Sustainable Product Regulation, which got launched in May this year, which is a very holistic view of how sustainable a product needs to be in certain categories. It's starting with the highest impact categories, kind of the apparel industry, food, all of those sorts of areas, but it will eventually trickle down to our industry, and that's the piece of legislation that might potentially have a marine specific element to it.
If I can just add as well, insurance and financing as well are two big components that will probably end up shifting the dial more before international regulations.
Okay, thank you. I like the way you call taxation incentivize, but that's another debate. Any question from the audience? Just one. We have time for one question. No? Yes? No? Great. We're good on time. Thank you very much to the three of you. Don't forget the photo. And so for our next panel, we're going back to, I would say, going back to the roots. We're going to talk about wind. Obviously, when you look outside, even with the challenge, we've got the energy class, the solar class, the open sea class. There's not much sailing boats around. When you look outside the marina, it's mostly motor yachts. But there's been some evolutions in wind propulsion. And to be able to talk about these evolutions as, in a way, it's not even an alternative energy source, is a primary energy source. I'd like to have Simon Schofield, who's the CTO of Bar Technologies, to come to the stage and to deliver us a short keynote about wind propulsion systems today. Please welcome Simon.
Okay, thank you very much, and thank you for joining me. You're right, wind is not something that's new to the marine industry, of course, and especially to the shipping industry. And there's a bit of a revolution going on right now in the larger shipping community. So, as you said, my name's Simon Schofield, and BR Technologies was actually born out of the back of the America's Cup. So, at the end of the Bermudan cycle, we took kind of the knowledge and some of the tools and the team and formed the technology business. It's very similar to a Formula One team, has a applied technology business. It's the same sort of guys. To specifically to be involved in projects to decarbonise the marine industry. And it's quite widespread. We do foiling electric boats but and sailing boats and all sorts. But here we're to talk about wind propulsion on ships. So there's various wind propulsion devices now being deployed on commercial shipping, and it's important to note these are devices that are available and being commercially delivered right now. So although we're looking at alternative fuels and other things to decarbonise the shipping industry, a lot of those are still a long way ahead, they're a long way into the future. These are things that are being delivered right now. And they come in various guises. You've got the rotor sail or a Flettner rotor, which works on the Magnus effect. It's effectively a spilling cylinder, which produces lift. Then you've got rigid wing sails, which it's kind of what they are, what they say they are. And then you've got a soft equivalent. Then you've got things which look more like a traditional sail on a sailing boat. And then vented foil systems. And these are quite bluff devices that then use either suction or blowing of air to to manipulate the boundary layer and create more lift again. The aim of all the devices is to obviously produce as much thrust as we can. Of course, wind is a free source of fuel, and it's 100% carbon free once we've installed the devices. And we're seeing them being fitted on both retrofits and new builds. And the low-hanging fruit definitely at the moment is kind of bulk carriers, tankers, ro-ros, not the container ships and cruise ships and those sorts of vessels, which, because of infrastructure, are much, much harder. And we're seeing reductions in fuel consumption anywhere from a kind of 4 or 5% for a small device, right up, well, obviously, to 100% if you're 100% sailing, but we're seeing 50+% reductions on real devices. And you can see on that graph on the right, there's been a big acceleration in uptake of installations. That's massively out of date already. I mean, that's supposed to be the whole industry. We're doing more than that right-hand graph by ourselves. So, one thing that's important to remember is we are using the wind propulsion directly at source. So the source of power is delivered to the vessel, and we use directly at source. There's no conversion of that energy, there's no delivery of that energy, and the energy costs related to that. And there's no land-based infrastructure required, of course. If we look at the future fuels, and believe I'm not saying they're a bad thing. They're absolute necessity, and they work very well side by side with wind. But if you look at producing a green fuel, you need to produce obviously green power to start with, and if you take wind, convert it to electricity, transport it, convert it to a synthetic fuel, burn it in an engine, then you've got propulsion losses. Out of the wind energy you originally capture, maybe only 10% of that goes into actually propelling the ship. Whereas obviously with wind, you get it and you convert it and use it directly. And of course it's free. So our product is called Wind Wings. And what you're seeing here is the largest installation. So it's 37.5 meter high aerodynamic span. It's about 50 meters off the deck, and they're 20 meters in chord. So they're real big devices produced from steel and composite, and they're fully automated, which is really important for the seafarers and the ocean-going crews, that they don't need to be sailors to operate these vessels, and that's critical. They literally turn them off or turn them on. They look after themselves. They fail safe, and the acceptance from the crew has been much higher than I expected. They fold flat onto the deck, so when we go into ports, we can reduce the air draft, so they can get under bridges, or the same in bad weather. And then it comes with kind of routing and management and tools to cover that. So here's a couple of example installations. The top right one is a Kamsarmax. So this is a type of vessel, for those of you not in shipping, that would transport a whole array of loose goods, from coal to soya, iron ore, anything loose. These vessels kind of transport, and they're kind of the trampers of the sea. So that top right one is it belongs to Mitsubishi, and it's used by Cargill, who's a huge American agricultural company. And since launching last year, that vessel has stopped in about 40 ports in 4 continents, so it's done a full trip around the world. Has 2 wings, as you can see. The other one's very different. It's a much bigger vessel, so it's a Newcastle Vax, 210,000 deadweight ton, and that's transporting iron ore effectively from South America to China and just going backwards and forwards. As I was mentioning, you can see they're upright, they fold, and actually making them robust enough for port operations is key. The salvadors, when you enter port, they just want to load the ship as quickly as possible, and they're not generally particularly careful. So making them robust and not interfere with the operations has been a big part of the challenge. In terms of savings, obviously savings are very route and wind dependent. If there's no wind, we're not going to save anything. If it's really windy, we're going to save loads. So what we do is we look at traditional shipping routes. The IMO has a good selection of routes that we use. And when we look at those routes and we look at the average savings, each of those wings is saving about 1.5 tons of fuel, a traditional marine diesel fuel per wing per day. In good conditions, obviously the savings are much, much higher, 6 tons or even more. I thought I'd just finish with a final slide on what we're actually producing in reality, because as an engineer, I can sit here all day and say we kind of save loads of fuel. But when we look at some results, and this is from DMV, and this is on the Pyxis Ocean, the smaller of the two with 2 wings. And you can see here we're operating in kind of 20, can't see it on the graph, but yeah, about 20 knots of wind, 10 meters per second on the beam. So not horrendously windy. We operate up to 50 knots with these wings up. But in those conditions, it's reducing the fuel consumption of that ship by 30%. We've had all these discussions about how future fuels are going to be expensive and they're going to be difficult to source. Of course, if we've got wind propulsion on the vessels as well, it's enabling that wind technology, and it's working hand in hand. So we're seeing a lot of new projects on new builds where they're dual fuel vessels, and they're fitting wings as well to reduce their operational costs and their bunkering requirements. Thank you.
Please keep a seat because you'll be joined by Simon Vatin from VPLP, if he's here. Yes, he is. Who's a managing partner and is going to tell us also a bit more about what they do at VPLP. And then we'll ask them a few questions when it comes to the yachting side of it. You need the clicker?
Yeah. Hello everyone. Thanks for having me here. My esteemed colleague Simon has already covered a lot of the basis of that technology, so I try not to repeat too much and bring maybe some complementary informations and other insight on this technology. So we at VPLP, just very briefly, we're a naval architect company founded about 40 years ago now, and since the beginning we always had one foot in the racing sector and the other in the yachting, mainly on multi-hull design and multi-hull optimization and innovation. So with these two components of our activity, they have always been feeding each other in terms of innovation and technology development from the racing, feeding into yachting innovations such as, for instance, sail plans or weight management or production structure optimization. More recently, since about 10 years ago, we also started looking at effectively wind-assisted propulsion for shipping based on America's Cup technology. Very similar path to actually BER company, which we actually personally we have crossed paths in the Bermuda America's Cup back in 2017. So small world. More recently, we really extended that technology transfer and development into shipping with the development of a particular wind assist technology, a soft sail, which would fall into the category of a soft sail, which has been launched on a 120-meter Ro-Ro last year. I'm not going to really repeat what Simon has said on the various technology and the benefits. I'm more going to maybe talk to you a bit more about how and what this could mean for the yachting technology. Effectively, we've seen this uptake and this innovation both from the racing feeding into the maritime, and we strongly believe that there's also a path for something new in yachting, which will be softening the frontier, if you want, between what we have today between a motor yacht, which is a very typical usage, look and feel, and a sailing yacht, which is also a very different object. I believe today with the use the positive upside of effectively carbon emission reduction, or is the ability to for the industry to propose something new to their owner, which would be a hybrid motor yacht with a significant wind assistance. So you trying to really blend the two usages into a new type of yacht, where you would have the benefits of wind assistance, which is again, as Simon says, significant emission reduction on the propulsion side, without having to have the hassle, if I may say, of managing a complex and large sailing system. With this automated wind technology, you would effectively have a fully automated, fully controllable from the wheelhouse wind engine that you could use. So it really opens up to a new type of yacht, really hybrid in the sense that your propulsion is hybrid, where the wind propulsion would blend into the mechanical propulsion and propose an efficient energy mix for owner and operators. And today we really believe that we want to abolish that kind of hard frontier between sailing and motor yacht with the use of that kind of technology. Thank you.
Thank you. Thank you. Simon or Simon? Simon. I obviously already have a few questions for the two of you. We can see how, well, as you said, racing is helping develop solutions. We can see how shipping is actually an early adopter in a way when it comes to wind-assisted solutions. Obviously, motor sailors have existed in the yachting for a long time, and yet can't see anything out there. Do you have any idea why?
It's a good question. I think sailing with the traditional soft sail image has always had a very typical retro look, retro feel, and in higher end yachting it's been quite emphasized, and we do not have today the image of a modern sailor or motor sailor. There's no such thing, and with these effectively modern sailing technology, some of them are really suitable for yacht. Not all of them, because clearly there's some industrial feel or noise or other constraint that I see that would not be applicable directly to yachting, but some, such as rigid or soft sail, for instance, soft wing, sorry, could open a new door, a new era.
Yeah, and I think the other side is simplicity, as you mentioned before. You know, sails are a bit of a pain. They flap around. You know, we're both sailors, but they are a faff. If you can sit in the wheelhouse and press a button and forget about it, just like you do your engine, it just makes life so much easier.
Well, you can see that. I mean, obviously, everyone in the yachting industry knows Maltese Falcon. It was created quite a stir, and the fact that you can do everything now at the push of a button. But when you speak to shipyards, when you speak to naval architects, designers, in the exchanges you have with them, when you tell them that, okay, well, you look at the technology, 30% on average reduction in energy, already we could be reaching closer to what the IMO is asking for. When you look at the fact that with the technologies you've developed, press a button, sails go up, go down, easy, no space, no need for, in a way it's easier to handle than ammonia, obviously, and less corrosive. What's the next phase? In a way, the technology is there, it's being applied in the shipping industry, so how do you see the next phase of that being able to be adopted by the yachting industry, or more the yacht owners?
I mean, I think we're going to see in the next 3 to 5 years a massive uptake in the shipping industry. You know, we're involved in 8 different yards at the moment in China, so I think it's going to become something you're going to start to see more commonly at sea, and I think that will then become a norm, and then hopefully the owners and the yards start looking to that technology and goes, how can we make that look cooler? How can we super yacht it rather than a big industrial unit? And how can we then implement that into the design of a vessel? I don't think fitting wind technology to a traditional motorboat is going to work. Maybe occasionally, but it's got to be a whole new look at what that concept of vessel looks like.
What you're saying is for the next generation of yachts that are being developed now and going to be built in the next few years should already look at integrating. So the retrofitting side of it is not really necessarily
I don't think so, no.
relevant.
Yeah, I tend to agree with that. I think it's more going to be played in a new build. Looking back a little bit at how we've been working on the shipping industry, it actually took a lot of time and a lot of persuasion to the shipyards and to the players in that industry to convince the earliest adopter, if I can use that term, of that technology. And everybody we've been speaking to, in 2017 to 2019 was, yes, that's great, but I don't want to be the first. And the moment we had the first or the first two and the first five, then the uptake, as Simon said, is going to be quite massive. And we can see it now. We can see the graph. There's about 50 plus today. The same on order units, all technologies included. And as far as the yachting is concerned, I'm pretty sure it's going to follow the same path. We're talking to potential owners and shipyards, and everyone realizes that yes, they see the benefits, they see the figure, the technology is mature. We need the first one or two owners and projects to start making that statement.
Thank you. One of the things is this is quite a trendy. Yachts are catamarans, the fact that they're more efficient, and obviously when you talk about sailing boats, and catamarans are comfortable, stable, efficient, reduction of energy, everything. So there's a trend on that. The fact is your solutions can be applicable. You don't need to be a catamaran. You don't need to have twice as much beam to be able to operate them and have them on board. So what would you say to, obviously there's a number of representatives from leading shipyards here. What would you say to them to say, well, what about integrating the possibility of our technologies onto motor yachts?
I'd say come and see us. No, thanks for making the advertisement of the catamarans and multi-hulls. I didn't pay for that, and I appreciate that. We've been long advocates of this kind of platform. That being said, I think there's really a case where you don't want just to plonk 1, 2, or 3 sails on a traditional design. It opens up a whole new range of possibility. For monohulls, obviously stability needs to be managed and accounted for, but in terms of it being a hybrid propulsion mode, it can be really tailored. The amount of energy you save by propulsion, or the amount of propulsion you have to take on by the wind, can be tailored, and you can tailor the impact on the design. If you want to do a pure sailor, then it's going to be very impactful on the design. And if you want to aim for something around 20-30% reduction, then the impact can be more managed.
I think another side benefit, which certainly the significance of it took us by surprise on the ships, and I'm sure it will have exactly the same effect, is the increasing comfort at sea with them up and deployed as well. They act as a big motion damper, and they actually make the vessels much more comfortable to be on.
Thank you, gentlemen. Any questions from the floor?
I have a question for BAR Technologies. As a naval architect, I would be interested in your opinion on, let's say, if we would design a new 60-meter yacht that would do 1 season in the Med and 1 season in the Caribbean, and then sail from the Med to the Caribbean once a year, and sail from the Caribbean to the Med once per year. Would you say that rotor sails, rigid wing sails, soft wing sails, or ventilated foil sails would be best for that?
They've all got their pluses and minuses. So you'll find that the rotor sails and the ventus foil sails are their strong point, if you like, is when you've got a continuous beam wind, and they're pretty efficient in those conditions. The wing sails give you more flexibility, so they're obviously still very efficient in a beam wind, which is why we've both got multiple elements, so we can change the camber. But when you are in a more of a headwind or a stern wind, the wings become much more efficient than the other sails. So I think we both sit here and say you should fit wings, of course.
Thank you. Another question? One last question? Yes?
For both of you, related to the previous question, for more commercial aspects, did you have figures about same scenario? What could bring your solution in terms of emission reduction to a client, to convince a client to install any kind of sail assistance on board? Don't know if my question was clear, but do you have figure to compare, to bring on the table for commercial acceptance for clients?
Yeah, so in the shipping industry, there's obviously lots of different efficiency ratings. There's CII, CII, EEXI, EADI, Fuel EU, and they're all either directly or indirectly credit having wind on board. Traditionally, when a client comes to us, we'll do a set of performance simulations based on their vessel and the routes they trade on, and then give them some statistical analysis based on historic weather data. This is how much fuel you're going to save, and this is your emissions reduction.
Yeah, I think in complement, we eventually when you assess multiple technologies for a given operational profile, this is what we do, and eventually you start forming numbers as, you know, such or such equipment from such or such manufacturer on a typical route. Again, this is more mature on the shipping now, but we can derive some typical operational profile for yacht, even though it's much more complicated and varied. And eventually you will say, okay, such and such units on such and such typical usage is equivalent to that many kilowatt or kilowatt hours saved over a trip. And then with, you know, specialist engineering or naval architect firm, you start to have a feel for the market and the potential saving in hard numbers.
Yes, hi, my name is Claire. I have a question. Do you take in consideration the weight that you add on the boat, adding these wings?
Yeah, that, and obviously we are reducing the cargo carrying capacity slightly if you're keeping the same load line on a retrofit, for example, and that additional weight does obviously make the vessel slightly less efficient. There's lots of other things involved, kind of leeway, rudder angle, propeller efficiency, and that all has to be put into the mix when you're calculating the fuel savings.
Thank you, gentlemen. I actually do have one last bit of a question. Honestly, can you make them look good? Jokes aside, I mean, when you look, and we're talking Oceanco, right? You've got yachts like Black Pearl is obviously magnificent sailing yacht. You've got Maltese Falcon as a prime example of. So obviously, when it comes to the design of these technologies being implemented, I guess for yacht owners it does make a difference. So, is there things that are?
Well, it's a very good question actually, because we've been doing a full loop between, you know, starting from racing or high-end yachting, which is obviously very aesthetic, and it's very typed to some kind of aesthetic, but there's definitely an aesthetic there. Trying to do the whole kind of work into making it an industrial product, to scale it up to industrial production level, to make sure that the ROI are acceptable for commercial owners. And now we see the interest and the uptick in yachting, where we're going not in reverse, but closing the loop and say, okay, now we have that industrial product that we have really maximized its cost efficiency or work on that. And exactly what you're saying, how can we make it a little bit more aesthetic now and more eye-pleasing to the yachting industry? So we're working on it. effectively, or the industry is working on it.
Thank you, gentlemen. Please give them a round of applause while they're taking position for the photo. And then the next session, I think, draws a lot of interest from many people. We talked about wind as a natural source of energy, obviously, with new developments. And now we're asking a question, which is something that's kind of become trendy again, was completely put to the side for many, many years for many reasons. Nuclear in yachting. And to talk about nuclear in yachting as a vision or a reality, I'd like to call on stage Engel Jan de Boer from Lloyd's Register, who's the yacht segment director. Renaud Schouten from Fedship, who's a senior specialist in all the developments, and Daniele Bottino, who's business development manager at ABS.
I don't have a clicker.
You don't have a clicker. Rono, do you have a presentation with a clicker? Oh, you don't have a clicker. Who stole the clicker? There it is. You're first. You're first. In the order of appearance.
Right, okay. Good afternoon, or good morning still, ladies and gentlemen. Sorry for that. Welcome, and for something completely different here today, which hopefully will stir up quite a little bit of discussion, and that's the intent of today. The first thing I want to do is just give you a compliment. In fact, I stood here about 5 years ago during this same event, whereby we talked about the energy transition we are about to embark upon about 5 to 6 years ago. It is good to see that finally, after 3, 4, 5 years, generally speaking, there is a good uptake in terms of what we can do in order to demonstrate our social and environmental responsibility. Because that's what I asked for about 5 years ago. I said, this is an opportunity for the industry, for the yacht, particularly for the yacht industry, to demonstrate its responsibility. At the time, I was a little bit disappointed because I felt there wasn't enough activity. Today, it seems that the majority of us are even talking about 2050, the IMO 2050 regulations, which are not applicable to yachts. But at the same time, it is good to see that everybody's talking about it and that we do want to take that responsibility. So a great compliment. So until now, we've talked about methanol, we've talked about hydrogen, we've talked about ammonia, we've talked about wind, all sorts of different kinds of fuel. What I'm asking you to do is exactly what John F. Kennedy said a long time ago. Change is the law of life, and those who only look in the past or present are certain to miss the future. Embrace the future. Please be a little bit more positive and don't lock yourselves down when you start thinking about nuclear. I know it's scary, or it might sound scary, but for all intents and purposes, it is not really. I'll go very briefly through it. Why nuclear? Why now? Because there are different kind of technologies available nowadays, soon coming onto the market. Very similar, if you think about it, what we talked about earlier today. We talked about ammonia. We talked about the new engines coming onto the market. Very similar with nuclear, small nuclear reactors, which can actually fit inside a yacht. The technology is available, currently being live tested, and the first units will probably hit the market from, I would say, 2029, 2030 onwards, which isn't that far away, frankly speaking. If you look at the energy transition we're actually going through, it's quite at an accelerated pace. Cost and supply issues around alternative fuels at the moment. When we talk about methanol, when we talk about ammonia or hydrogen, there is an issue with respect to the cost of the fuels. In fact, the technology behind nuclear fuel is not that complicated. It doesn't require a lot of interaction by crew. In fact, no interaction by crew. It is passively safe, and through life economics nowadays seem to demonstrate that they are quite comparable to fossil fuels. It obviously depends on the use of your project, but then again, you can wonder whether sort of the through life economics of a yacht makes sense anyway. generically speaking. And of course, last but not least, but most importantly, it will achieve the carbon goals which we need to set all together. It is inherently safe. It is straightforward onboard technology, infrequent bunkering. In fact, depending on the type of reactor you want to use, there is either no bunkering for 30 years, or you might need to bunker every 5 years. There's no issues with respect to the energy consumption on board, because you just use as much energy you want, really, strictly speaking. There's no emissions. And there is a strict adherence to the depleted fuel management. And of course, there is a lot, and I know there is a lot of questions about it when it comes to, ooh, but it's nuclear, ooh, there is terrorists, ooh, it's a bomb. Let me dispel all of those, all of those thoughts, but I'll wait for the questions from the audience, because if not, I'll be taking up too much of your time. There are headwinds, and the biggest headwind really is the top one. The biggest headwind is the regulators. It's the likes of ourselves, it's the likes of the flag states, it's the likes of the port states, as you can imagine. Public perception, it's difficult. Somebody earlier today on stage said, the biggest challenge is perception. In fact, we shouldn't be calling it nuclear reactors. Let's call it heat pipes or heat generators, or whatever you want to call it. But the public perception needs to be addressed, and there is an urgent need to have some sort of education. Nuclear reactors will be there. Nuclear reactors will be there on ships. Nuclear reactors will be there on shore for the powering of not just entire countries or cities, but also for the powering of hospitals, chemical plants. Dow Chemical Plant in the US has recently ordered a small molten salt reactor in order to power their chemical plant. Is society ready? We're getting to the first stages of acceptance, particularly by the younger generation who have not been exposed to the likes of the stories of Chernobyl and Fukushima and other incidents and accidents, which, by the way, are completely irrelevant to the type of technology being introduced, and which has been around for the last 70 years on board of ships already. We need to train the crew. There is a bit of a steep nuclear learning curve, and of course there is a need for us to address the ports and the insurers. So that's from my side. I'm not a nuclear expert. I'm a marine engineer, naval architect, but I have to admit, having gone through sort of all of the material and speaking to our nuclear experts within Lloyd's, of which we have quite a few, because there is a lot of development happening, not just in the commercial world. You might be surprised to hear it's actually also happening in the yacht world. There is a need for us to further engage with you to make you understand that it is a feasible option. But I'll leave it to Ronno to explain why it can and why it cannot be used, right?
Thank you.
Thank you. Indeed. Can we make a nuclear yacht? That's a nice question. I think first of all, can we design and engineer a nuclear yacht? Here you see a picture here that was made in 30 seconds, so that's probably the easiest part. Can we engineer it? Yes, we've been looking in it. It seems feasible. Of course, it has influences on the boat. It's probably a little bit bigger. It's probably heavier, but it could fit into a yacht, and I will show you a picture a little bit later. The next question is, could we build it? Then it becomes probably a little bit more difficult. We started 10 years ago. I think we did some research in it, and we talked to some suppliers, and we asked, can we buy a small reactor? And they said, yeah, maybe probably in 10 years time. And if we ask that same question nowadays, we still get the same answer. So can we have it? Yeah, probably in 10 years time. So is it possible? Maybe later on. And then the last question, of course, could you operate it? And then I think it still becomes a little bit more difficult, because first of all, it's at least currently pretty difficult to privately buy or own a nuclear reactor. And secondly, indeed, what Jan said as well, there's some perception. Would you like to say to your guests,
You have this cabin on top of the nuclear reactor, and it's probably safe because there's some shielding around it, and you can sleep there for a few weeks in a year. Then the level is low enough. That still needs a big change, I think, in perception. On the other hand, we see some possibilities. Of course, we can have what you see on the right. We can have the nuclear reactor on board, but we have also other possibilities. Of course, onshore nuclear reactors we already have, and like you saw in the presentation before, the disadvantage is there's a big energy loss. We go from nuclear energy, we have to convert heat to electricity, electricity maybe to hydrogen, hydrogen maybe to methanol, capture carbon, we have to transport it, we have to convert it again. So there are big losses in the conversion. Same, of course, if you have a big floating nuclear reactor. It would at least solve our methanol problem. It would be nice to refuel somewhere in the middle of the ocean. And of course, the last one, we can have it on board. The issue there is that on average on a yacht, you have a very low load. So what you would see next question, and that's also why it makes it less effective. The average power consumption of a yacht is simply very low. This is an example where you see that around 90% of the time the boat is simply laying in port, being for anchor. So you have you use your power only for, what is it? You use only 5 or 10% of the power. Then you have some time at cruising speed and a very, very limited time at maximum speed. So in the end, you use probably less than 10 or even less than 5% of the maximum production. So as a nuclear reactor is expensive, and a small nuclear reactor is even more expensive, it becomes even a lot more expensive if you use only 10% of the capacity. So could it be a solution? Yes, it could be a solution. Is it very effective? Probably not. And I have another, just to show you, could we do it? Yes, this is the some research we did. So you see actually in this one 2 reactors, a bigger one for the aft one for 4 megawatts, and the smaller one of 200 kilowatts, so more for the hotel load. Funny enough, the sizes are not so different. That's because of the whole shielding around it. In the end, is it necessary to have 2? Probably not. Probably 1 reactor should be good enough, so that will save you some space. You still see it's pretty big, and it's pretty heavy because of all the concrete around it. So again, is it possible somewhere in the future? Yes. Is it likely to happen? We probably think not so soon. Thanks.
Thank you. Thank you, Rono. Daniele?
Thank you. I need my notes because I have some news or some new concept to add to everything that has been said. There's not so much, yes, to say. So just to complement what Engel is just saying, a little bit of myth busting. Safety, it's probably much safer than what it is oil and gas industry, especially when it comes to the number of casualties during any phase of the production, extraction, transport, and everything else, and not to mention the damages caused to health due to the emissions. So if we're getting into a GHG-free energy, nuclear would probably be safer than all the others. The technology of managing the wastes is sufficiently defined, well advanced. And it's really more about how to dispose and how to change the public opinion about that. So the concept that I would like to introduce now regarding item number 3, the exposure to radiation. Apparently, there are studies that indicate that eating one banana has exposed us to some like 10 to the -7th sievert, which is the unit of measure of the explosion. So if we include this BED, banana equivalent dose, one banana is 10 -7 sievert. If we consider the X-rays to arms that we take when some of us break arms, it's 1 microsievert. Basically, it's like eating 10 bananas. A flight to Seoul to Singapore is 40 microsievert, which is 400 bananas. And again, apparently, according to global guidelines and EPA, the Environmental Protection Agency in the US, they say that the limit of radiation over 1 year before it becomes dangerous is something around 50 millisievert, which is basically eating 500,000 bananas, if my calculations are correct. So that's that. We've been already covered this one about the technology around the power consumption of yachts, and then we can say with around 10 megawatt installation, one micro reactor would be able to support that. But I guess Fedship has already covered that. Micro reactors, by definitions, are something around 1 to 20 megawatt of electricity. And just to close, having a look at the market overview. I mean, how can we use nuclear? In fact, some of that has been already also covered. Producing electricity, transforming, making new fuels, but also offshore production, offshore installations that are also can be like a first step towards an implementation, just to see how it goes and just to see if that is safe. That's all for me.
Thank you, Daniel. Nice ones, everyone. Very interesting. I'm sure there's plenty of questions. I only have one, and then I'll leave it to the floor because I'm sure they'll have plenty of questions. You did mention cost. How much more would it cost to have a small reactor, nuclear reactor, on board to produce your 10 megawatts, for example, the micro ones, compared to a traditional solution in terms of the capex? Put it this way. If a wealthy owner wants to actually try it,
to be honest, I think that's what you said. There's not a clear idea because they're not commercially available. We know they're pretty expensive, but how much is difficult to say.
Initial indications show that at the moment, if you were to purchase one which is ready for 2028, 2029, following the successful testing which is happening at the moment, it's probably going to cost you about 50 million. The idea is that these small nuclear reactors, whether it's the micro reactors or heat pipes or the molten salt reactors, they fit in a 20-foot container. They're actually transportable, and the idea is that at the moment they're actually building the factories who are going to make these as a production. And again, so it's not just limited to shipping, it's not just limited to yachts. There is no doubt about it, there is absolutely no doubt about it, that within the next 5 to 10 years, put it at 10 years, there will be small nuclear reactors being used on board of perhaps the larger ships, but also on land-based industries, such as large hospitals, large chemical plants, large cities, for example. You can actually make use of this. So there is a demand in terms of production. And if there is demand in terms of production, the prices will go down.
But not private use.
No, okay, so there's a lot of discussion about private use, of course. As you can imagine, you know, private use of a nuclear reactor on board of your ship. It poses a few questions here or there. No. If you want to buy a nuclear reactor, for all intended purposes, the most likely scenario is that you're not going to buy it, you're going to lease it. And the owner of the plant itself will be the producer of the plant. That is the most likely outcome. We're currently working together with the International Atomic Energy Authority. We're working with the IMO. In fact, we're chairing the working group on the revision of Chapter 8 of SOLAS, which addresses nuclear-fueled ships. So there's already regulation in place. But that terribly needs to be amended because it's outdated regulations dating back from 1981, where the technology was slightly different. So there's a lot of things already happening in that domain, and with the IAEA and with the IMO, so these two sort of regulators need to join together in order to come up with a solution as to how are you going to allow these small nuclear reactors on board of ships. Now, let's not forget, there's already more than 700 units over the last 70 years which have sailed our seas with nuclear reactors. And I'm not just talking about naval ships, we're also talking about icebreakers and some other units. It's not new technology, it's just that the amount of energy being produced by these small reactors is now of suitable use for small-scale industries like shipping, like yachts, like hospitals, like etc., etc. So there is a big movement happening, and it is part of the energy transition, and the energy transition is accelerating.
Yeah, just to add on what Engel just said, we really have to make a difference between what is commercial and what is Navy. As we know, American Navy and not only Russian navies, they've been using nuclear ships, and this is enriched nuclear material, which is totally different with what we're talking about today. And again, regulations are being, the regulations are being thought of and on this basis, basically.
Can I just add something? You know, I think it was a great presentation by Ronno, and I think it's good to see that there is a number of shipyards and there's a number of owners at the moment within the yacht industry who are looking into this possibility, which is great. Let's move forward. Fortunately, the technology nowadays with these small nuclear reactors is that you can adjust the power, so you don't need to run them at full power all the time, which I think is of benefit. So that will put a little bit of a shunt onto the presentation. So that is something which can actually happen. It is one of those things. Another thing is this. We're afraid of radiation. Okay, please have a look at the number of equipment and component manufacturers now dealing with the building of these small molten salt reactors and heat rods, and read up about sort of the technology and what is possible and what is not possible. Read up about sort of the radiation as well. The radiation effects are, let's put it like this, there's more radiation coming out of the central station of Oslo. There's more radiation coming out of the White House because of the material being used. We have nuclear officers working for Lloyd's. They've been on nuclear submarines for more than 20 years. They're exposed to less radiation than an airplane pilot is flying for 10 years. It's this mindset which really needs to change. The technology is there. It is an intrinsically safe technology. I could go on about this for the rest of the day if you want to, but I'm not. But all I'm saying is, please have a look into it. Look at some of these equipment and component manufacturers. Find out exactly what's happening, and then form your judgment, if you want to call it that way.
I find it interesting that the two regulators, if you like, or representative of classification societies, are very optimistic, proactive about nuclear being an opportunity for the future. The fact that these regulations already exist, that has been in use for many, many years. But when we speak to Ronno as a shipyard, building yachts, and we see his presentation, unlike on the other alternative fuels where we're saying, well, the regulators are actually a bit behind, not necessarily the classification societies, but the regulators, generally speaking, are a bit behind track on the technology. Here we're having a kind of opposite view, where on the shipyard side you're saying it's like it's a good idea, but the reality of what's going to be feasible is not so simple.
No, I think the experience is, like I said, that the expected availability and also the prices is not yet here. Like I said, 10 years ago we spoke to suppliers. They said in 10 years' time. I still don't think there's something available in 10 years' time. But also the experience is that the cost of big nuclear reactors, but also small nuclear reactors, is in practice much higher than the first expectations. And that, so I think costs combined with, in the end, the limited use of the reactor on board doesn't make it a real efficient solution. I think it's simply much more efficient to have a bigger, more cost-effective nuclear power plant on land, floating somewhere, converted to any other fuel or energy storage way, and have that on board.
Thank you. I'm sure there's some questions.
Yeah, Dan Chatterjee from Rolls-Royce. So as we are producing nuclear power units for submarines and also small nuclear reactors, I share fully your technical view on that they are safe. My question is, you pointed out the acceptance of the society, and we see in the energy production market there seems, besides Germany, but there seems to be now acceptance. And now talking on yachts, which is a luxury product, and always the debate is system. Do you think it will really go that far, that even that kind of bit exposed product would be accepted, let's say, or get this positive view on nuclear, that it will go so far? Because I think power generation is a must and so on. I think that drives that we see some acceptance there.
I guess you need to look at the horizon or the time frame. I mean, it's really difficult to say it's not gonna happen. Point is when it is going to happen. We're making comparison with the other alternative fuels as to acceptance being slow. We're not saying that is going any faster in the nuclear field. There is interest because the decarbonization brings us there, but whether it's going to happen soon or later is going to be difficult. And as we've been mentioning, there is this private ownership of this nuclear or heat pipes, how you want to call it, thing that is going to be the property and is going to take a long time and is going to be very complex, I guess.
Hello. I just wanted to make sure that to clarify or to see your view, this is primarily seen as a nuclear electric propulsion solution, not like nuclear mechanical, like, for example, some of the Russian icebreakers are, which directly use the steam turbine to generate torque on the propeller shaft.
Correct. At least that's what we're investigating. Yeah.
Maybe if I can share a short, because this was a short one. What about the the nuclear battery approach, which ostensibly solves the proliferation and nuclear fuel handling issues, which are also quite a liability in normal reactors where you extract the fuel and replace it and so on. Like treating the reactor as something that's good for the entire lifetime, and basically it works while it works on the scale of 30 years or 40 years. Thanks.
When you talk about proliferation, you mean what's going to happen with the nuclear fuel afterwards? Yes. Yeah, the nuclear fuel afterwards. The good thing about this technology is, as it is allowed within Europe and not in the States, unfortunately, at the moment, is that you can recharge the batteries if you want to. You can actually see them as a battery. You can actually recharge the fuel and then use it again. If in the end the nuclear fuel is as good as spent, that spent fuel can actually then be used for medical purposes. And in fact, there's a very strong demand at the moment from space exploration, out of all things, which wants to make use of the leftovers of this type of nuclear fuel being used in these molten salt reactors, for example. Which again, quite right for you, may come back to your earlier question, molten salt reactors, they run at 700 degrees C. That's what you use in order to generate steam. You have a steam generator and you make use of the required electricity. Hence the fact that you're able to adjust the electricity demand.
Bernhard Obern from Lösen again. Rather than asking a question, I would rather make a statement, because there's many alternatives on the road of transition. We've seen methanol, ammonia, nuclear, hydrogen, and all those technologies. They probably will be safe. There will be application in different types of industries, but rather for yachting industry, I deeply believe in methanol, because it has, I think, the best parameters for designing the general arrangement plan regarding weight, availability, and what Ronno showed us in his presentation, I think, is quite obvious that a nuclear reactor is not used 100% permanently on a yacht. So there might be applications for other ship types, but then I would rather put the nuclear reactor, if it's safe and everything, on land and produce the fuel that you need on the yacht, and I believe that will be methanol. Thank you.
Thank you. You're cheating, because you're pushing for methanol again when this was the first one and we're done with it. So you're not being fair on the nuclear side. And we haven't spoken about hydrogen yet, which is for tomorrow. So there'll be some further debate. Thank you, gentlemen. The next topic will be also of very much interest and something quite new. But before we get to that, please give these three gentlemen a round of applause, and we'll take the picture. It's all right, it's not nuclear, so it's fine. Don't worry. Thank you. So for our last session, and we are not too bad on timing, a different topic, which in a way has nothing to do with fuels or alternative fuels and solutions for propulsion, whether it's natural or not. It's a trend as well, obviously. Since last year, there's been a lot of talks about artificial intelligence. And so it was decided that this year we should also tackle the subject of artificial intelligence and see to what extent it is possible to link artificial intelligence with yachts, boats and yachts generally speaking. Of course, artificial intelligence is a very wide topic. So one of the key aspects when we think about artificial intelligence and yachting and boating, generally speaking, has to do also with autonomy. The fact that, it's like cars driving by themselves. Well, the idea is to what extent artificial intelligence can be applied in yachting for autonomous navigation, autonomous docking, and of course other application where artificial intelligence will improve efficiency in the management of the vessels. So for that last panel, I'd like to call specialist in artificial intelligence, Matko Barisic, who is the R&D Programs and Partnerships Manager at ABB, Kevin Defey, Senior Vice President Mobile Automation at Rolls-Royce, Dimitrios Papageorgiou, who's Associate Professor in Nonlinear, let me find a way to read that properly. Associate Professor in Nonlinear and Fault-Tolerant Control, Technical University of Denmark. We're going to get very technical. And last but not least, Zillard, who's been running the Energy Boat Challenge on the development this year, and who actually happens to also be a control engineer, and he's with the Yacht Club de Monaco. Please welcome them, and I'm sure they will entertain us. You have presentations, you have, so please take the clicker, and you've got microphones here,
Yes.
which should be on, or I can leave you mine.
Can you hear me? Yeah, okay. Great, great to be here. It's an amazing place. I've only ever been to Monte Carlo once before 30 years ago when I was a teenager, and I don't really remember how it was. For obvious reasons. So, yes, our outlook on advanced yachting is that essentially we pursue a strategy which is stepping stones to autonomy and facilitating functionalities and capabilities to autonomy. We don't really necessarily believe that in yachting, which is essentially a kind of marine tradition which is all about the experience, the care, and the service of the crew for the vessel and for its guests, we will, see full autonomy because there's just not a business case for it. However, everything we do where in other segments we want to pursue this road as far as it goes, which is to autonomy, is equally applicable to making the yachts safer. That's, I think, the first value add of autonomy enhancing technologies. And then also making the experience of sailing aboard such a vessel involved and interesting, both for the crew, so as to make it an attractive career, and also, of course, for the owner and the guests. In general, then, what is driving these types of technologies is two undisputable trends, which are listed up there in the center, and then 5 mega trends that we see in the labor market and society. So first of all, and now I speak in general about all the sister industries, including shipping, we see an aging out of the generations of mariners out of the market at a rate faster than the replacement rate from the marine universities and academies. And then we also see, due to geopolitics, the closure of opportunities for arbitrage. Essentially, certain markets that are very well known as producing mariners for the global market, like Ukraine and Russia, are no longer able to satisfy that demand. And then what we would like to provide to the mariners, to the fewer mariners that are entering the market, is first of all, we want to make technologies that would involve the traditionally excluded classes from the maritime domains, like primary caretakers in family units or peoples with handicaps. We would like to improve their work-life balance, the daily rhythm of their work, the qualification and certification process, and open up opportunities for digital work. And that's basically my last slide. This is just a teaser because there's a lot of multimedia here. The lower right is from our foremost thus far autonomy implementation in Singapore, a fully autonomous harbor tug in Singapore, which is displaying a fully autonomous collision avoidance performance. And then we have a bunch of other situational awareness stuff going on here. That's thus far from me. Thanks.
Thank you. Thank you. I'm sure we'll ask you to play that and explain it to us a bit more in detail after each presentation. So let's get to the next one, and it should be on. If it doesn't work, take mine.
Okay. Great, thank you very much. Kevin Daffy from Rolls-Royce. I've been involved with autonomy since 2016. Doing various demonstrators and building technology, talking to the IMO, working with class societies. So my perspective on autonomy, especially in the yachting market, is we're not going to make vessels completely autonomous. That's not the realistic aim. But there are a number of sort of technologies that can come along and can aid human decision making on board the ships. So if we look at some of the trends in the marine industry, one of the areas is about cost consciousness. So crew reduction. So what are we talking about here? We're actually talking about moving some of the roles maybe from the ship to the shore using remote operations. So you can think of a highly trained chief engineer. Maybe we don't need such a highly trained engineer on board, but we can have them in remote looking after a fleet of vessels, for instance. And we can use remote technology to help us there. Availability and reliability is another topic where actually artificial intelligence and machine learning is being used. We use both for looking at the state of our engines, trying to understand them, looking at prognostics and diagnostics. So that technology is relatively mature now and being used, along with digital twinning as well. Safety and comfort's a really interesting topic. Now, quite often people have said autonomy is going to make shipping completely safe. That's not true. The same is in autonomous cars. You know, what we're seeing is we do see accidents that happen from autonomous cars. And safety at sea is sort of polarized a little bit by navigational errors, but we have to remember that there are millions and millions of safe decisions which are made by captains at sea which have prevented accidents and safe passages continue, but we don't measure them. We only measure the bad outcomes. But ultimately, some of this autonomous technology can help and aid to make even safer decisions and actually reduce the navigational errors that might occur, as it were. And then we just had some great presentations today talking about sail and nuclear and alternative fuels. And I think some of the autonomous technologies, we're developing one called Artificial Chief Engineer, which can be looking at the state of health of all of your equipment on board. We're taking technologies which we use to control microgrids. And if you can schedule, you know, propulsion from sails, propulsion from batteries, power from alternative sources, you know, artificial intelligence and machine learning can be used to schedule those powers and really optimize the way the vessel is being used, and to also think about the best way of navigating. Even the fishing industry is using some navigational technology now to look at the best way of getting from one point to, you know, to the nearest port where they can sell their fish at the greatest profit, as it were, taking into account the current and the weather in getting to that port. So we've introduced a number of different products, and actually last week I took an order for the Coda, which is a helm unit, which will, you know, replace a bridge wing from a large vessel like one of those being built in the Netherlands. And that helm unit, you can control the vessel from any point on the vessel. You can go to the bow of the vessel, or you can go to on the port or the starboard side. And they've actually designed the vessel to take out one of the bridge wings to allow this sort of belt pack helm unit to be used. The Cooperate system that we've been developing as well is used for remote operations, so you can control the vessel remotely from any point on the vessel or another vessel or the shore. And then ultimately the Co-Watch is very similar to what you saw from my colleagues here at ABB, which is a completely situational awareness type system, which can be used to aid navigation, not to replace the navigator, as it were. And I'll leave it at that. Thank you very much.
Okay. Thank you very much. So, first of all, thanks for the invitation. It's a great pleasure for me to be here and be able to be part of this discussion. It's also my first time at Monaco, and I can say that I'm stunned by the beauty. I was also very impressed yesterday looking at all the activities that going to the bottom floor, and it's very promising for all the initiative and the interaction between development and, of course, the industrial stakeholders. So. I chose as a pitch presentation to go a little bit historically with respect to activities that we're running in the university I'm working at, which is the University of Technical University of Denmark. And the reason for that is because, first of all, I could take the opportunity to give you an idea of what the trend is with respect to exploration in notions of artificial intelligence and autonomy in the maritime sector. But also to try to highlight a little bit the interaction between academia and industrial stakeholders and see how this interaction shapes more or less the direction of the initiatives that we're taking. So the group I'm working has been more or less within the last 13 years into this sector of maritime autonomy, or at least highly automated operation. We started with when we were approached by the Danish Navy, and they gave us more or less a toy, very high-speed, agile watercraft, and said, can you make this pretty much operate in a highly automated manner? That is, that we don't have to remotely operate it all the time. And the funny thing about these vessels is that they are both fish and birds. So when they start like picking up really speed, they just like jump out of water. So you have a new set of dynamics there. So you need to kind of like have quite sophisticated low-level controllers to control this thing. Well, the results definitely were very optimistic. They were not the greatest, I can confess, but they were very optimistic. So the Navy asked, okay, but could you do it without any pilot whatsoever, completely autonomous? And that started a discussion and a research direction that led to the next project, this electronic outlook. Because if you want to operate autonomously, or not autonomously, having big muscles and great physics, which is the equivalent of control algorithms, is not enough. You need to have perception. You need to have also some sort of intelligence. And in order to have perception, you need to have a lot of instrumentation on board. So this electronic outlook project started comparing the reaction times of real navigators by looking out and see how many vessels there are there and so on, with the instrumentation and the delivering of some sort of information. Then, once we had this information, or at least this comparison set, we started exploring how we could automate all the steps that navigators do in order to take decisions. That was the next project. Of course, these were very exploratory, so to say, discussions. So we went into a flagship project, this shipping autonomy, which was sweetly placed right in the middle of the Corona period. So it hindered somehow the activities. But there we started exploring how we could develop an entire autonomy stack, a software stack, starting from instrumentation all the way to the full-fledged autonomy software. And that was some very, very nice experience over there, and I will detail in the next slide. So these are, since we started putting a lot of software, so to say, in the discussion, cybersecurity, resilience, and safety came, of course, into the play, because if you have tankers and big ships completely autonomously automated and operated, well, you really need them to be, let's say, secure in terms of cyber attacks. And then we started asking a bit more exotic questions, in the sense how we can encode the good seamanship notion into algorithms. So these last risk projects that they tackle these questions are ongoing research, so I'm not going to spend more time on that. So as a university, of course, we went full throttle into the high and full autonomy operation. And of course, when we were enthusiastic about our results, we met with some very well-founded skepticism from industrial stakeholders that say, maybe you should hold your horses and talk first as decision support, or maybe unmanned or unintended bridge. And that was, of course, very mature, that it's actually one of the roles of the industry to hold the horses of the universities in these regards. And when we started looking onto these discussions that were springing out of this kind of debate, we figured out that the central part, especially when you try to include artificial intelligence and machine learning, was what we call the situational awareness. And this is the main and central point on all navigation aspects, because in order for decisions to be made, you really need to have a very good grasp of the situation. And that's where things are getting complicated with the involvement of artificial intelligence, because artificial intelligence, for big part of its nature, is some sort of black box, which is very hard to guarantee. So the results of. So enter the discussion, legislation, regulation, compliance to standards, and all these interesting topics. So now we are at the pinnacle of development of technologies, and of course, eyeing on how we can make them compliant to regulations, so we can have a chance to put these technologies actually in practice. And I will leave this presentation here.
Thank you. Okay. So Zilad is the last one for today's presentation. And I think he's got a number of things to tell us. And then there'll be a few questions.
So welcome everyone. I can tell you this is not my first time in Monaco, but I have a lot to tell you today. First of all, you might be wondering why does the yacht club have a control engineer on site? This is a good question. And secondly, you might be also wondering what is the connection between the yacht club de Monaco and autonomous systems and AI-based technologies. But before answering these questions, I would like to make one step forward. And first of all, introducing the Monaco Energy Boat Challenge for you, which is just happening right out there. So currently we are providing opportunity to our participants to try their knowledge in the field of decarbonization in the maritime industry by deploying and implementing high efficiency, zero emission propulsion systems. So currently participants who come here from research institutions and universities, they can build their own zero emission vessels. As a way of demonstration, they can also have a little fun because the way of demonstration is racing at the moment. Currently we have the Sea Lab class, the Energy class and the Solar classes available. And please, I also would like to invite you, all of you, after this insightful conference, to visit the quayside, because the future is just happening right out there. So I see many zero emission boats and high performance hydrogen boats as well. So it's quite interesting. And after that, so in the past few years, we have noticed an increasingly growing rate of utilization and deployment of pilot assisting systems, digital twin developments. So the Yacht Club de Monaco had a few questions in mind, which we had to address for the future. During the Monaco Energy Boat Challenge, we have witnessed basic implementations from basic pilot assistance systems to the digital twins, which are being developed currently by many of the teams. And we just popped the question, what is next? Is it full autonomy? So our answer is the following. As a demonstrator and facilitator of novelty technologies, the Yacht Club de Monaco would like to expand its portfolio within the Monaco Energy Boat Challenge. So, ladies and gentlemen, please welcome a new era of the Monaco Energy Boat Challenge from 2025. Please welcome the YCM AI class. Normally there is a cool music in the background. So as you can see from the video, we are targeting fully autonomous systems in the future with implementing cutting-edge technologies. And we would like to also expand our portfolio, not just with decarbonization developments, but also with digital ship operation and autonomy developments as well. Thank you very much.
Thank you. Thank you, Zelat. Couple of things to add on to that is that obviously there's a number of shipyards representatives in the room. And a number of you have already started taking part in the challenge of working with the university, doing partnerships. We invite you to do more, to have more shipyards collaborating with the university, building partnerships and programs. As was mentioned before, it's obviously a number of these engineers will become your key engineering and R&D teams in the future. And obviously when it comes to artificial intelligence, the development of new autonomous solutions to be implemented on these prototypes, I guess it makes full sense that the two are combined between the shipyards, the industry, and the students. So thank you for the initiative. Zilard, it's quite a nice evolution when it comes to advanced yachting in Monaco and beyond. So thank you again for that. I'm sure you have some questions for our panelists about the use of artificial intelligence. I only have one in a way. you said that, okay, the objective is to be autonomous, not to like remove, everybody. But at the same time, you said, well, you can have fewer crew on board because a lot of the operations can be done in a way remotely, for example. When we see what's happening in the world of the automotive world, where it's happening, but then suddenly it's no longer happening. Cars are autonomous, but yet the regulators are saying, well, you know what? I mean, there are some incidents and stuff. What do you foresee as being the next steps in terms of being able to actually not only just technically apply these technologies, but make them validated by the public in a way, and then by the regulators? Even if you keep people on board, when you drive an autonomous car, you still have to have your hands on the wheel as well. So what's your perspective on, okay, we understand it technically speaking, but next phases? Who wants to answer? All of you? Yep.
Yeah, so I think what's very important is for regulators and class societies to recognize that I really like from Dimitris that situational awareness is key. And the regulators should first and foremost take a good hard look at how they regulate and how is risk assessed on the bridge for the instrumentation that enables lookout. So because autonomy and better situational awareness comes from sensor fusion and inference about the situation at large in toto. And currently the regulation and the way that you get class notation and so on demands, for good reasons, that you have sort of totally distinct siloed systems. And the good reason is that if some of them fail, you still have the others. But there should be some recognition of the fact that you can have more safety, more situational awareness by allowing to harmonize or to at least let this information be exchanged and live in the same environment, sort of glass bridges or the equivalent of glass cockpits and so on. So that's one. And then the second one, really shortly, I think since shipping is quite a bit more, has quite a bit more infrastructure once you're close to the shore. Of course, you sail out into the wide open blue and then you don't have any infrastructure. But the ports are huge capex investments and VTSs and so on. So I think there's also regulation and standardization in the industry to be done on improving vessel-to-vessel communication and vessel-to-infrastructure communication. Right now, we only have AIS, which is like totally not appropriate for this stepwise approach to more and more autonomy and more automatic function. Yeah.
Yeah, so I think you're right. Acceptability is going to be key, and it will be done in small steps. If you think about your cars nowadays, lane assist, lane control, auto parking, adaptive speed control, these are all features which are now pretty much accepted standards now. You used to have to pay for them. Now you get them as a standard on even most cars, Skodas and other vehicles. And I think we'll see that gradually come into the yachting industry. There'll be auto berthing. There'll be some form of sort of assistance in terms of navigational plotting and following a course. All these can be done. The DP world, if you're working offshore, quite of that is completely automated with two-man crews on board platform support vessels. So, that's what we're seeing. And I think, getting away from having a highly qualified 20-year veteran chief engineer on board every single vessel, working with tug companies where they'll take that person off and have them on land. The great thing about having somebody on land is it opens up diversity. People who are disabled, people with families can actually work in remote centres. They're not committed to go to sea for 3 months. So these are some of the ways in which the technology will help.
But coming soon then, really coming, yeah.
Yeah, I totally agree. And first I'd like to make a small distinction It could be a bit controversial, I'm warning you. What we call today as AI, it's not really, it is definitely artificial, but it's not really intelligence, in a sense that it's cognitive and it could make some sort of informed decisions on the fly. Which means it's closer to regression and curve fitting, so to say, from a technical point of view, rather than some sort of like artificial agent that can think and so. So with that in mind, we can definitely see that when it comes to perception, to looking at what's out there and maybe classification of vessels and so on, or interpretation and conflation of information. This is something that if it's not there in the next 5 years, it will be very, very, very soon, because it has proven and guaranteed to be working quite well. So we will have, I can foresee that we can pass from a phase of completely human-operated vessels to human in the loop, where humans are intricate parts of the decision-making and so on, towards autonomous but human on the loop, where they have some supervisory, so to say, authority. Also because they there has to be a need for responsibility attribution in some sense. So at the point where decisions can be suggested by the intelligence, then it really becomes true intelligence, and that's where we will have, we will take, I foresee, longer time in order to pass this through the regulations. And one of the ways is actually to structure all these software algorithms and also like the modules exactly to comply to the responsibility attribution that humans have. So you have one for the navigator, one for the chief engineer, and one, for example, for the overall captain, so to say.
Yes, so basically I totally agree with Dimitrios, and you also, Laurent, mentioned the crew and the people involved in this whole ecosystem. I think, first of all, what we have to highlight that autonomous systems are not equal to self-driving boats only. So currently we are facing a huge demand in the maritime and in the yachting industry for labor force. How I can see and how we can see this, that AI and autonomous systems, they will help optimizing the crew. So that's one important thing. And they will help us to find solutions in those segments when we face the lack of labor force. So I think this is really important to highlight that why we are supporting AI developments. So as previously was mentioned, it's mainly in human on the loop, also in the loop, and I can see the fusion of this. And in the end, I think both the crew will be optimized and also the whole operation by AI and autonomous systems, not just self-driving, what we will see as the most spectacular result of AI navigation, for example.
Thank you. Yes? Yeah, brief follow-up. And then one or two questions from the audience.
So I think it's also very important to recognize like the difference in the drivers for autonomy enhancing technologies or autonomy in yachting versus maritime or shipping. And I think one critical issue, which is also something fun for example, our in-house and also out-of-house user experience experts and human factor experts to recognize, is that in yachting, indispensable part of the allure and the value proposition and the selling point is the experience of the owner and the guests, and crew do take part in that, and therefore I think the entryway for autonomous technology is a little bit different, is to allow the crew to more dedicate themselves more to the care and service aspect. And you said it well, that you know, in the labor market, it might not be the same thing if you're looking for an ideal deckhand or officer of the watch on a yacht and on a tanker or bulker. You might not be looking for same qualifications, same kind of people, and so on. And this is this autonomy technology can be a great equalizer, or at least help level the landscape in when people have a little bit differential set of skills with respect to what's required in different shipping and yachting markets. Yeah. Thanks.
Thank you. Any questions from the audience? Yes? If we keep it to one question, everyone will be happy, starting with me on the timing management.
And I will be short. AI is absolutely very useful for automation. In Norway, we have a number of automation projects now going on, but AI can be much more. It's the key idea of AI is you can process very quickly very big data and data from all over the world. So for preventive maintenance, for evaluating optimization routes, but much better that amount of data which you can process is actually the key application where we see AI will, in the shipping industry, be of tremendous help.
Thank you. It was not actually a question, but a statement. And on this final note, unless you've got something to...
Yes, maybe I can add something on that. That is why we named the class AI class, because we see a way beyond than simply autonomy and autonomous vessels on the water. So we do not want to limit the students and the researchers. So we are seeing the broader picture. Thank you.
Thank you. You can probably hear some noise outside. It's 1 o'clock. And so you can see that all the students are there supporting their boats because the parade is taking place. So it's a very nice sight. When you enjoy the lunch, then you'll be able to also see them. I would like to give these gentlemen a round of applause. One thing, next year we're going to try and have more women on the panels, because obviously it was very male-dominated this year. This is something where obviously the yachting industry also has some work to do, and in the engineering world too. But they're very good female engineers working in these universities, so hopefully they'll try and balance our panels better in the years to come. Many thanks, gentlemen. Please, for the last picture of the day. Many thanks to all of you for being here, taking part, being active, and contributing to the thoughts and discussions. I wish you a nice lunch, a nice break, a bit of a rest, and to go and enjoy the Energy Boat Challenge. Thank you again. Have a good day. There's a pair of glasses waiting for whoever's lost them. Male, female, we don't know. Reading glasses that are at the counter by the entrance. So if you've lost your glasses, you should be able to get them by the counter.
To take it slow. She's taking her time, making up the reasons to justify all the side. Guess she knows from the smiles and the looks, everyone's got a theory. Saying, Mama never loved her much, and Daddy never keeps in touch. That's why she shies away from human affection. But somewhere in her private place, she packs her bag for outer space, and now she's waiting for the right kind to come. I will fly you to the moon if you'll be my baby. Got a ticket for a world where we belong. So won't you be my baby? She can't remember a time when she felt needed. If love was red, then she was colorblind. All her friends